got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Gracing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody? What's up, Goose, bro? I've seen Goose in a second, dude. What's crack-a-lackin', Goose? Let me fix this. Nice. Okay. That should be working. I think we're live on YouTube and Twitch. I'll turn on TikTok in a second once we start doing questions. Nice, let me boost the volume a little bit here. Today is Monday. New week. I think all AP exams are done. We had a really, really good stream on Thursday. We helped out a lot of students. It was the day before the AP physics exam. Yeah, and if I go to like my channel dashboard to see how we did analytics wise, I think it was one of the best live streams we'd ever done. Ever.
That's dope.
Let me see. I have it here somewhere. What's up, Sensation? Ooh, yeah, it was this one. What's up? What's up? Good to see you, dude. There we go. Yeah, look at this. Oh, now I see you. You're good. My green screen's off. It's funny how it says there's only, what does it say? There's only 56 views. This is wrong. We had a lot more than this. Wait, what? One sec. This one was, yeah, look at this, 10,000 views. I don't know. Their analytics are all off. It's definitely not 56 views. I don't know, maybe last 7 days. Will that count? Oh, there you go. Okay, now it counts it. Okay, so that's actually people watching. 100 watch hours. That's really good. That's really, really good. 51. I thought we had even more. I thought we had up to 200. But okay. Anyways, regardless, it was a good, great live stream. So I appreciate everyone that came by. I hope it helped you out with AP Physics and stuff. Oh, at one moment? Yeah, I thought we had even more, though. I think Google's, not Google, whatever, their analytics are kind of weird afterwards. Because if I look at, this was the screenshot I took earlier. If it wants to load today. There we go. Come on. Come on. There we go. Is it working? Yeah, this is the screenshot I wanted to show. Yeah. So this was concurrent. We had 121 peak. And then average almost looks like our average is almost 90 or something. But yeah, that was super good. Yeah. I have a midterm 3. The last midterm in this physics class that I'm teaching at UCLA. That's going to be coming up. One second, let me fix my camera here. No, that's too far. I want to go the other way. There we go. Okay. So we might have some people hopping in the stream asking about that. Otherwise, other news. I was in Texas for the weekend, seeing my friend for his 35th birthday. That was fun. Ooh, nice. Yeah, we got a lot of good questions. Shantrik's got some. AMA's got some. Sensation, you got some questions too. I like that. Binomial expansion. That's a good one. What else?
What did I write? What is this shite?
What is this shiza? with the B. Yeah, the Shizer with the B. Oh, also, if you're in our Discord, I think I want to load today. Yeah, there we go. Okay, cool. We still have the Wibbly Geometry Challenge going on. So, pretty easy, the steps here. You just sign up for free. Go through. Our friend Nick has done some really cool work on creating like a geometry course. Takes like 15 minutes to go through, and you can get entered in to win some prizes. So, if you have any questions, you can always use this side of the chat here that has Nick's in there, so you can ask Nick about things. But anyways, okay. What's up, 1K? Good to see you, dude. All right. Other than that, let's get into helping you guys out with some math and science questions. If you have any questions you want us to go on the stream, go click that link down below there, actualdiscord.com/submit. You can upload a screenshot and we'll go over it live on the stream. Okay, cool. Without further ado,
I got a physics pop question for you.
Ooh, physics pop question. Okay, start off with the physics pop question before we do this stuff.
Okay, so you're in a plane and the plane's going, and you're at the equator.
Okay.
And you're in a plane, and the plane goes nuts. It does 16,000 kilometers per second.
Sure.
Per hour.
Whatever. Yeah. Okay.
What would the temporal discrepancy be between you and the people on the ground?
Ooh, that's a good question about like quantum physics. Well, this is called special relativity. Actually, sorry. This is called special relativity. It would be pretty negligible, honestly, but it is real. There is definitely a there's because you have different accelerations, I think. Oh, also, time moves differently based on a dilation factor, which I think is the square root of 1 minus v over c squared. That's why that would be, but we can go over it. Here, let's start it off. I'll do that. That's a good one. Okay. Welcome everyone, office hours. My name is Dr. Gold's Actual Education, streaming help you with math, science homework.
Nice.
All sorts of fun stuff. Sensation asked a good question, where he said, if for instance you were in a plane up here, right, and it was flying at what you said, 16,000 knots. That's very fast. 16,000 knots. It's just like a super
kilometers per hour.
16,000 kilometers per hour. Okay. That's a really fucking fast plane, right?
I know, but just to keep it within sort of human possibility.
Okay. If we could get, I mean, what is the fastest plane out there? What's like the speed of a scramjet?
Mach 10.
Yeah. 7,000 miles per hour. Okay, so I mean, this is reasonable. It could happen. Yeah, it could happen. Yeah, Mach 9.6. That's nuts. Okay, so I mean, this could happen. Okay, and so you're asking like, what's the difference in the time between these people here, like holding like a clock, and then people on the ground? Okay. So there's a thing called time dilation, in which time appears like slower in frames where you're traveling close to the speed of light, and the factor for that is gamma, I believe. And I gotta see what gamma factor. Yeah, there you go. That's the link. Yeah, that's the website. You got it. Yeah, Lorentz factor. This is it. So it's 1 over the square root of 1 minus v squared over c squared. Okay. So that's equal to 1 over the square root of 1 minus v squared over c squared. What's up, EDs? Okay. And what's up, Poison Mouse? So if you're going at v is equal to 16,000 kilometers per hour, first of all, we got to put that like into meters per second. So I first want to say, okay, how many meters per second is equal to 16,000 kilometers in 1 hour? This is where like some simple stuff, such as stoichiometry comes in handy, because I want to convert from hours into seconds. So the first thing I'm gonna do here is I'm gonna say, okay, well, 1 hour is equal to 60 minutes, right? And then I have 60 minutes is equal to, or sorry, 1 minute, sorry. 1 minute is equal to 60 seconds. And the reason we do this is because hours will cancel with hours, minutes will cancel with minutes, and then now we got kilometers per second. Now to get to meters per second, I got to do one last conversion, which is that 1 kilometer is 1,000 meters. Nice. Okay, cool. So let's do a little bit of math here with our calculator. Let me get my calculator out. Okay, cool. And so that would be 16,000 times 1,000 divided by 3,600. That's 60 times 60. Okay. Yo, what's up, Recky? So that's going to be 4444. So this is 4,444.4 repeating meters per second. Okay. So this is equal to V. Does anyone know what C is equal to? C is a special one. It's the speed of light. That one is equal to 3 times 10 to the 8th meters per second, okay? So, if I want to calculate my time dilation factor here now, okay? Yeah, good. 3 times 10 to the 8th. That's equal, so that's gamma, which is equal to 1 over the square root of 1 minus, so this is going to be 4.4 times 10 to the 3 over 3 times 10 to the 8th, and then that's going to be squared. Okay, so now we got to do a little bit of math. Okay, so I'm going to do 4, so whatever this number is, it's 44444, divided by 3 e to the 8th. Okay, kind of tiny. I'm going to square it. And then I'm going to do 1 minus that, which is going to get me that, 0.999998. And then we're going to take the square root of that. Okay. And then we're going to do 1 divided by that. So you can see, actually, it's not a very big difference at all. It's pretty much fucking 1. Yeah. So, yeah. Could you notice the difference in time here? Going at 16,000 kilometers per hour? You really can't. So, it's so tiny. This is basically just 1. Let's say, for instance, you created like some like super jet that, I don't know, could do 100 times this. Okay, so instead of 4.44 times 10 to the 3, let's say it's 4.444 times 10 to the 5. Okay, so here let's just move the decimal over a little bit. So I'm gonna move the decimal. There we go. And then we're gonna square it. Oh, actually, no, sorry. We have... Yeah, no, that's okay. And then we do 1 minus. Okay. And then we do the square root of this. I want something that's at least... And then to the -1. There we go. So, very, very, very small decimal. Okay. So, let's say we were recording something... So, that's the factor at which it changes. So, if you were to calculate... if you were to calculate on a stopwatch the amount of time, let's say for instance that it took for an hour, right, which would be 3,600 seconds, okay, then on the ground that clock would register this 3,600 seconds as this times this, so it would recognize it as 3,600 and then an additional 0.003. So gamma here is equal to 5 zeros, 2, 3, 3, 4, 5. 5 zeros, 1097. This is the time dilation factor. So this is how much time dilates or gets longer. It's also the amount that distance contracts with like length contraction. Yeah, special relativity, exactly. This is special relativity. So for 3,600 seconds measured, which is basically equal, that's 1 hour. The difference in time would be 3,600.003949. And so this is your difference from 3,600. And so that's around 3.9 milliseconds. Okay? Gamma is an awful letter. In your language, it means stealing? What language is that? That's hilarious. So yeah. So Sensation, to answer your question, even if you had a scramjet that goes 100 times faster than current scramjets can go right now, and you were to measure for an hour in the air, which would take an absurd amount of fuel to travel that fast for an hour, you would only measure a difference of 3.9 milliseconds. So it's very, 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 it's very small. You have to be going really, really fast.
Or very far.
Or you have to be measuring a long amount of time. So this actually does play into an effect with satellites, for instance, because satellites orbit the Earth pretty quickly, right? And then the satellites also are up there for a long amount of time, so they're more likely to have like big differences in time that you can measure. Yeah. I think someone in the YouTube asked a good question about physics though. Who is it? Oh, it was Adiz. Adiz said, "I just joined the stream and saw some physics formula. Yes, next year I'll be majoring in physics. Congrats, dude. That's cool." Could you briefly explain what your channel is about? Yeah, so we're a nonprofit based in the U.S., and what we do is we help out students with math or science, anything that they're doing, basically from middle school up through like early college. And we also incentivize students to like do well in school, life, and whatever, because you can earn points in our Discord for doing various things. And then when you do those things, you eventually build up enough credits to buy like gaming gift cards and stuff. So if you want to check it out, I have like a quick little video that explains everything we do. I think if you go to the main website, actualeducation.net. Yeah, it's very cool. I appreciate that. Yeah, no, that's cool. Actual education. Can I spell today?
Are you English letting we down?
I'm getting really... There we go. Okay, if you click on this website, here you go, and I'll give you the link in YouTube. You can learn about like what we do as a nonprofit. You can also, you can donate if you got cash. That's cool. But if you look at, for instance, here on our mission, this is a little video that we produced, minus the ads, that explains basically what our nonprofit is and why we came to be who we are. So if you want to check that out at some point, where the hell's all my links and stuff? 1 sec. There we go. There it is. Okay, there you go. There it is in the chat. I wish I had time to ask questions, but I have to go to bed. Uh-oh. Sleep is good.
Very late.
Low-key, I was scared of physics, but I'm halfway through the unit, and I'm finding it way better than chemistry. W, dude. Yeah, I love physics. I think physics is... Why do you like physics, 1K? Why do you think this is... Why do you think this stuff, for instance, is cool? I think it's cool because there's always just so many different ways to solve a question, and physics kind of gives you that freedom of you can just do however you want. Chemistry is kind of like that, but there's a little bit more memorizing, a little bit more rules and rigidity, but physics is like kind of more open. 1K says, it's fun solving the problem like lots of math. Yeah. Poison says, I'll ask some non-inertial questions. Oh, thank you, man. Welcome from Turkey. That's cool.
That's dope.
I think it's always cool when we have like students that find us from like all over the world. I'm trying to think the craziest place we've had someone like tune into our stream from. What do you think that is?
I was
had, like,
to good editing.
We had some people from Japan. I've had New Zealand, of course. From Belize is Ethan. Yeah, but yeah, it's cool. 1K has some good questions. Ooh, speed of light in a refractive index. Okay, that's a cool one. Let me pull this in. And then we have some other questions that people have submitted. Yeah, for real, I'm not trying to memorize how to make different bonds and solutions. I mean, some of that stuff is cool, but then, yeah, some of it, like, fucking blows. No. I would love to send in my questions, but they're in German. Well, you can send them, and I can try to translate them with ChatGPT. That sometimes works. Chandrix, yeah, or we can have Sensation he can start translating for us.
Thanks du, das ist eine Modifikenspieler.
Chandrix says, I like physics because you don't have to memorize stuff and has real life applications in math. 100%. I agree, totally. Yeah, it's very cool. Okay, this was one of 1K's questions. Chaotic had a good question with, this looks like E&M type stuff as well. I'm just going to put them up here because we will get to them. So this is another one. And then I'm trying to see, Shantrix, you gave some good ones in. And then someone said prove by induction. Ooh, that's a tricky one. I do differential equations. That is true. I can do differential equations. Is this like just solve for x, Shantrix? Is that what this is? And then someone else, I think, was asking something. Dude, with... Wow, integral of arctangent? Oh,
Sorry, but I've got to mention this now while we're on it.
All right, mention it.
Jesus, how many people are on YouTube now?
I think... Oh, I saw 200 for a second there. Which is dope.
What?
Yeah, we had 200 people live viewing the YouTube. Wow. What's up,
Welcome
YouTube?
in, everybody.
Welcome in.
Please hit that button that looks like this. Where
Yeah, the little like and subscribe button. Yeah. We get more exposure, and it helps us to help more students and stuff.
And it just looks cool. So, you know.
And it just looks fucking dope.
That's dope.
Okay.
We like them thumbs up buttons.
We do. We love that. We love that like button. Let me see what 1K had. Let me do 1Ks real quick, because I feel like this one shouldn't be too bad. It says, light travels through a salt crystal that has a refractive index of that. What is the speed of light in the crystal? So the speed of light is the same everywhere in a vacuum, but definitely not with a refractive index. I believe that n is equal to... is it v over c or c over v?
It's been a while, I don't remember.
I know. Oh, n is equal to c over v. Thank you, Edis, it is. Yeah, cool. All right, awesome. So, yeah. So, if this is equal to 1.52, so you have 1.52 is equal to v over c. Oh, that's pretty easy then, right? That just tells you that the speed of light in the crystal is equal to 1.52 times c, which is, you know what, that's approximately like 4.5 times 10 to the 8th meters per second. Yeah. Oh wait, 1K says it's c over v. Oh, so I messed this up. My bad. Wait, did I type it in wrong? One sec. What? 1 sec. Index of... Yes, c over v. Okay, not v over c. Okay. We're backwards today. C over v. There we go. Okay. So v is equal to c over n. That makes sense, because I want this to be lower. So v is equal to c divided by 1.52. Which, that, oh, so yeah, what? That's like 2, right? Isn't that just 2 times 10 to the 8th meters per second? Because this is basically like 3 times 10 to the 8th. Yeah. So yeah, slower. Okay. Cool. Hopefully that helps you out with that. Not too bad. I will get to this. Whose was this? Who asked this? I think Chaos said they asked this. Which I forget if Chaos is in our... Who Chaos is in one of our chats. Oh, that's you. Okay, cool. Chaotic.
Someone's called Crisps Walker, as in Walker's Crisps.
Yeah, Walker's Crisps. Yeah, that's the name for the chips, the chippies, or yeah, what we call is like potato crisps.
No, it's chips. Wrong. Chips are hot boiled.
Chips are the big potatoes, but
big
crisps.
Fat chips.
Yeah. Y'all have some interesting flavors in the UK, right? Like, was it like prawn cocktail?
Prawn cocktail, I can't stand that shit.
Yeah, dude, prawn cocktail flavor, dude. Yeah, I'm like, what? Why would you make your salt and vinegar supreme? But then, like, this flavor, I'm just like, excuse me, like, what's going on here? Like, why are you having your chips taste like fucking shrimp? Excuse me. I don't know. That sounds
so
bad.
do you. That's Lay's chips right
motherfucker.
there.
But was our what? Sorry.
I said, so do you. There's Lay's chips right there.
Yeah. Well, they're not really found here. Okay. Victoria Day today. That's cool. What's Victoria Day? Like Victory Day? Queen Victoria Day? Okay. In the figure below, an electron is accelerated from rest through a potential difference. Ooh, that's cool. This is a potential difference. So we're going to say delta V is equal to 500 volts. And then inject it into a uniform magnetic field. Once in the magnetic field, it completes half a revolution in 3.0 nanoseconds. What is the radius of its orbit? Use conservation of energy to find speed of electron at the injected point, and then use cyclotron equations. Oh, this is cool. Cyclotron shit is dope.
Good job.
Okay. So I gotta remember how this works. I think it's like changing kinetic energy is equal to 500 volts, basically. Let me see if I can rederive this. So, QE is equal to F, right? The force on an electron is equal to Q times the electric field. And then electric field divided by distance. Is that equal to potential? I always forget what this is. Yeah, let's derive it, dude. Let's do it. I just need to see what the equation is. It's something with that. Yeah, V over D is E. Okay, cool. Oh, V equals E times D? Wait, one sec. Not prawn cocktail. Yeah, okay. Oh, V equals ED. Yes, good. Okay, because there's a work equation there. Yeah, that's what I wanted to say. Sorry. So V, so this is potential, is equal to ED. Okay. And then if I want to figure out, so this is actually kind of cool. So F, right, which is, so this is the force on an electron, is equal to Q times the electric field. And this is something cool. Force is also equal to MA, right? So we could say that, okay, cool. That tells me that Q times E is also equal to M times the change in velocity over the change in time. And I forget what I want to do here. Because I have, okay. And then from this tells me that electric field is equal to V divided by the distance. Okay. So Q, and this V is different than this. This is a velocity. Sorry. And this is a potential. Which here, let's write the potential as just phi. We're going to do that. Yes, I'll get to that. Yeah, I'm just showing how this works. So let's call this potential phi, just to make things a little bit nicer. Finally, someone doing something good and productive. Yeah. What? You don't like the thirst traps and the feet picks? What? I mean, yeah, we can also do
Actually
physics.
feet.
Actual feet. Okay, so this is this distance, and then this is equal to M change in velocity over change in time. And then, man, I want something. I have distance, I have time. Work equals QV? Yes. I'm here for the feet as well, Carlos says. Yeah, I think I have to use work because the issue is that yeah, the distance divided by the time is going to change. Oh, I see. Because I also don't have... Well, I could figure out the time here, right? If we wanted to go like with the timeless equation, I could say that distance here is equal to 1/2 AT squared, right? And then the acceleration is equal to F over M. So that's QE over M. This is just like really, really messy. And then...
Martha says, my God, I haven't seen this stuff since high school. And don't worry, I've never seen this.
Yeah. I actually don't think I want to do this. This is too much. What's being derived? We'll get to the MV squared over R. I wanted to figure out, based on the potential difference here first, guys. I wanted to figure out what the velocity of the thing would be here. And I think what we end up doing is we just say that the potential, phi, is equal to the change in the kinetic energy. I think is really what happens. So here, let me. Yeah. Yeah. It's. Yeah. Okay. One sec. I need what it is. Oh, cool. I'm glad you think it's interesting. Yeah, if you just stick around and watch long enough, you'll start picking stuff up, dude. That's what I would say. Yeah. This is eventually what happens. We say that the
That's
change in
not broken.
What's up? What's broken? Oh, it'll.
That's
Oh,
the,
yeah, no. Yeah, I turned off Nightbot because it was doing weird things, banning people. Okay, this is the eventual thing we do, where this. And let me come up with why this is. This is the charge of your particle, and then this is the potential. It goes through. So, and then I'm saying this is phi. So I'm going to say that this is equal to, let's say this is equal to phi v. Now, why that is I believe it has to do with the work energy theorem, which says that the change in kinetic energy is equal to the work done on an object, okay? And in that case, the work done on an object is the integral of the force times the distance. So this is f dx, okay? But the force on a particle is equal to the charge of the particle times the electric field dot dx. And then E is equal to v over d is what it is. Right, okay, so watch. Electric field doesn't depend on the distance, neither does Q. So this is QE, integral of dx. And then dx, that's just equal to the distance. And then, so this is QED is equal to the change in the kinetic energy. And then electric field is equal to V over D, or potential over distance. This cancels. And that's how you get the change in kinetic energy is equal to Q times phi. Right? That's how that works. Okay. This is the thing that you learn. That's where it comes from. What angle would deviate from its path? Okay, so one sec, we're getting there. So first things first, we figured out that if you have a charge here of charge Q, and it travels between this potential of 0 volts and 100 volts, that the kinetic energy that thing is going to experience, the change in it, is just equal to the charge times the potential. So, I do some computer science stuff. Yeah, we can do some. But let's do this first. Okay, so 1/2 mass of the electron, and then we're going to say V final squared minus V initial squared, because that's the change in the kinetic energy, is equal to Q phi, which in this case, Q we're just going to say is E. So E is equal to 1.6 times 10 to the minus 19. And then phi here was equal to 500. V initial is 0. So V final, when it exits the 500, is equal to the square root of 2. So 2E times 500, so 1000 E all over the mass of an electron. Okay. Mechatronics? Yeah, we could do mechatronics. But let's finish this real quick. Okay. So that's the velocity. What's being derived here? Here's the actual question if you guys want to see it. We're doing a cyclotron.
Sorry, just that question. Are you some kind of genius? Why do I get this distinct impression he said that in like a really thick Appalachian accent?
Appalachian accent? What? I'm not Appalachian. I am from Texas.
Are you some kind of genius?
Are you some kind of smart person? I get plenty stupid on the weekends. I'm just smart during the week. Okay, so we have the velocity of this thing here, and we know that it travels like this with half a revolution being completed in 3 nanoseconds. Okay, so I'm going to say period 1. So period is going to be equal to 6 times 10 to the minus 9 seconds. Okay, so this is the amount of time it would take for it to do a full revolution, because it does half a revolution in 3 nanoseconds. Okay, so now let's derive some shit about like what happens in cyclotron motion, because cyclotron motion is pretty cool. So if you have an object here, for instance, and it has some velocity, initial velocity going in this direction, okay, and it has a charge. I think we said it was an electron. Cool, we said it was an electron, okay. It's going to experience circular motion here, and that's due to some centripetal force that acts upon it. So what we learn is from, I think it's the Lorentz equation or something, is that F is equal to Q, and then it's V cross B. Okay, so if V is pointing, let's call this like the x hat direction is this way. Let's say into the page is the y direction. So I'm gonna say that this is the y hat direction. One second, y hat is that direction. This is always like, the reason this is an arrow, you think of like if you were looking at a bow and arrow, like where would the tail be? The fin tail would be pointing into the page. And then so x, y, so that means z hat direction is going to be up. Okay. So this is where you can use your physics gang signs to do things if you want, or you can just rely on vector calculus, which this is going to be q, v, and then the velocity is pointing in the x hat direction, so I'm going to say x hat, crossed with b, which is pointing into the page, which is going to be into the y hat direction. So here, we're going to pull this out. We're going to say qvb, and then this is x hat cross y hat. And then what we learn, if you've done any sort of vector calculus, is that if x hat is this way and then y hat is this way, then this is z hat. And so x hat cross y hat is z hat. So this is going to be in the z hat direction. And now because Q, the charge on my electron, is negative, that means the force, F, that this charge is going to experience will be in the negative z direction. Which, if z pointed up, that means it points straight down. Okay? So this is where you get that we say like the Lorentz force, or Fe, is going to be equal to negative QVB. And what happens is, okay, so as this thing is moving out this way and it has a force pulling it in, it's then going to change its trajectory. It will no longer be moving straight this way. It will now be moving at an angle in this direction. And so what happens is, because now your velocity is changing directions, it's not all the way in the x-hat direction, the Lorentz force is also going to change directions, and it's going to be, so here, this would be like the new V, and it's going to have its restoring force point still towards the center, but like now at an angle. So the cool thing about this is that as this object moves around, it has almost kind of like a restoring force, which we learn in mechanics is called like the centripetal force, that is always going to point towards the center. Okay? And the magnitude of that force is always going to be QVB. So this is what we come up with. So if we look at dun 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 dun, yes, math, baby. So if F, right, is equal to QVB, and F is also equal to MA, and then this A right here is the centripetal acceleration, because anything that's moving around in a circular motion experiences a centripetal acceleration pointing straight in. Okay? We can then now replace this AC with V squared over R. Yeah, so watch what happens. This is really cool. So now this is going to be V squared over R. Okay. So, let's see. I think like one of the V's cancels. Yeah, the V cancels here, right? This cancels with this. Goodbye. So then I have QB is equal to MV over R. But what we know here is the period. What's up, math major? Well, this is physics, but it is kind of related. We said that the period, the amount of time it takes for it to do a whole revolution, is 6 nanoseconds. So we're going to describe some other stuff about things moving around in a circle, and that has to do with frequency. So for instance, frequency is equal to 1 over the period. Okay? And this is equal to the amount of revolutions in 1 second. Okay? And then there's some other really cool stuff about this. Is that frequency, so F is equal to 1 over period. We also know that omega is equal to 2 pi f. This is talking about angular velocity. So that tells me omega is also equal to, if I plug this in for f, is equal to 2 pi over the period. Okay, you may be wondering, like, why the hell are we doing all this? The reason why is I can use one final relationship between omega and v, and that is that linear speed v is proportional to the angular speed by a factor of the radius. So v is equal to r omega. So the speed at which this thing travels linearly is related to the angular speed it travels around, which the angular speed is related to how long it takes for it to do one of these oscillations. And then there's this factor of r. So the cool thing you get here is that if I rearrange this, for instance, to be v over r is equal to omega, now I can replace this whole thing with omega. So now I have QB is equal to m omega, okay? And then omega was equal to 2 pi over the period. So we get QB is equal to m 2 pi over the period. And then what are we solving for here again? Oh, they wanted the radius of the orbit. One sec. Because this will let me solve for B. And then once I solve for B, I can plug back in for V, and then we can go get R. What is the sign for period? It's this. It's this big capital T thing. Yeah. I was going to solve for the magnetic. This is the important thing. You use this all the time. Omega is equal to QB over M. This is called the cyclotron frequency. Yeah. So I end up solving for B here. Is there an easier way to just get without B? I don't think so. I think I have to solve for B first. So let's just do it. Okay. So B is equal to m 2 pi over tau times Q. So yeah, we don't know B. Yeah, see? That's how we got to solve for it, right? But then also from this, Femvox, you are right. So here, let's see if things cancel. I think we can come up with a cool expression for this. So from this, right? QB is equal to MV over R. So R is equal to MV over QB. Okay, so then here, let's use this. So R equals MV over QB, but B is equal to 2 pi M over period times Q. What's up, Muhammad? Or, yeah, that's the easiest way. Adis has the even easier way here, which is literally this. V over R is equal to omega, and then omega is equal to 2 pi over period. I like that. That's an even easier solution. All right, this is actually, I think, eventually, if I plugged all of this in for this, we would get it, right? You try potential equals D equals R over 2 dB dt. No, you don't need to do that. No. We don't need to be taking derivatives of the magnetic field. Yeah. This is it. R is equal to V times period all over 2 pi. And V, we remember saying, right, this was square root of 100 E over ME. And then the period is 6 times 10 to the minus 9 nanoseconds, so 6 nanoseconds. And this is divided by 2 pi. And then ME, I believe is, what is that? And the charge cancels too. Yeah, mass cancel. Okay, so it's 9 times 9.11 times 10 to the minus 31. So. Okay, so then let's solve this. I think we got this. So, where's my calculator? I'm gonna do 1,000 times 1.6 e to the negative 19 coulombs. I'm going to divide that by 9.11 e to the negative 31. Then we're going to square root that. And then we're going to multiply that by 6 e to the negative 9. And then we're going to divide by 2 pi. And that's going to give me r is equal to 0.0127. Which is, yeah, approximately 13 centimeters. Yeah. So I think this should be the answer. You had 1.26 centimeters. So I think you're off by a factor of 10. Is this right, though? Oh. Wait, 13 millimeter? Why am I off by a factor of 10 then? One sec. 1,000 times 1.6 times 10 to the 19. Good. Times that. Good. Square rooted. Divided by 2 pi. The answer... is it 1,000? Wait. No. Because here, we had 1/2 m v squared, right, is equal to q phi. And then phi, the difference in phi was 500 volts. Oh, you are right. Oh, dude, I'm so dumb. God damn it. Oh, man, I messed up. Yes, this is 1.3 centimeters.
What the fuck is this piece of shit?
Yeah, I screwed up. Okay. Sorry. I had this right, and then I just had a massive brain fart. To be honest, I've been teaching physics for like 5 hours today, so sorry. But yes, this is this. Yes, cool. Does that make sense, chaotic? Yes, and it is 12.7 millimeters. Yes. I think that's right. Yeah, cool. Consensus is yes. Okay, awesome.
Yes!
Congratulations. We did it. You're a genius. Wow. So many concepts. Yeah, there were a lot of concepts in that question. There was, yeah, changing kinetic energy is net work, which then we had to figure out force of an electric charge is Q times E, and then we had to do centripetal motion, right, circular motion, and we had to figure out centripetal acceleration. There's a lot. Now calculate the flux density. Oh God, dude, stop. I don't want that much more pain. Okay. Cool. Let me move this camera a little bit. There we go. That's what I want. Okay. What if we put the system right in the Schwarzschild radius of a black hole? Oh my God. Okay. Oh, and I see some good
reference.
Yes, what's up?
Future reference, if someone comes in and their name is Mohammed, you have to say, and I quote,
What
Salam
do I have to
alaikum.
Salam. That means peace be upon you, right? Salum alaikum, right? What it means?
Salam alaikum.
Salam alaikum. Yeah, there we go.
Wa alaikum assalam.
Malaikum salam. All right, let's see. This next question is from Shantrix. Good job, Chaotic. That was a fun one. Salam alaikum. There we go. Okay, cool. I figured it out. Yes. I almost dated a Muslim chick. It just didn't work out because, I don't know, I couldn't really understand Ramadan. Like, I think Ramadan's dope and everything. I think it's really cool that they have that whole, you know, showing that, you know, we're all human or something. And then if you fuck up, you have to, like, give meals to the poor people. So I think it's really cool. It's like a better form of, like, penance. Like, Catholic penance is just like start saying some prayers and shit. I'm like, what does that do? Like, yeah, go feed some people.
Go feeding people is fine, but starving yourself. But if you don't live in the desert, it's kind of pointless.
Yeah, Ramadan is too easy. I don't know, dude. You can't drink anything. You can't eat anything. You can't even chew gum. Like, I don't know. I would go crazy. I don't know how you guys do it for 40 days too. It's nuts. Okay.
Lent's easier.
Yeah, if I didn't have to do anything all day, then it'd be great. But if I had to like work and stuff, like, nah, there's no way I could fast during the day. My brain would turn off. All numerators are to the x squared. Well, this is x squared, this is x squared, this is x. So I agree. I'm going to multiply everything here by x squared. I'm going to multiply everything here by x squared. Yeah, x squared over x squared. Oh, when you get used to it, it's easy? Maybe. Yeah. I guess there's like an adjustment period, Mohammed. You're probably right. Okay, so if I multiply x squared through here, I get 9x squared minus 1. And then this, so 1 of the x squared cancels with this. So this becomes 12x minus 6, right? Okay. Is equal to x minus 3. Oh, I see something cool here. This almost looks like an x minus 3. Weird question. Why is YouTube only a vertical live? No, you're right. So YouTube is only a vertical live. If you want to see the horizontal, you can do that on Twitch. We've tried streaming to YouTube horizontal, and it just does abysmally. Like, the algorithm does not like horizontal. But yes, if you want to watch on Twitch, where it's a horizontal format, totally can. I think the link is, if you go to that actualdiscord.com/submit, there's a Twitch link there as well.
It's obviously better on Twitch. But for some strange reason, we get all the numbers on YouTube. Go figure.
Yeah, YouTube Shorts does like so well. Yeah, is this a 9 or a 4? What is this? I have a remarkable identity on the top. I think I do, actually. Yeah. And that's why I want to say it's a 3. Well, maybe I don't. Well, okay. I'm going to factor something out of this, just right off the top. I can factor out a 6 from this. So this is the same thing as 6 times x minus 2 on the bottom, right? No, wait, I fucked that up. 6 times 2x minus 1, which I do believe this is supposed to be a 4. I think this is supposed to be a 4, and I'll show you why. Because this, if we pull a 6 out, is 6 2x minus 1, and then this is a very cool identity. This is called a difference of squares. So anytime you have a squared minus b squared, that's the same thing as a minus b times a plus b. So the reason why I think that is because I think this is going to be 2x minus 1 over 2x plus 1. And then this is all equal to x minus 3. Right, Mohammed? I think so, yeah? Yeah, horizontal is more practical, yeah, but the majority of the views we get are from verticals. Yeah, exactly, and to cancel. Now, you got to be careful here, though. Canceling this out, I have to make sure to check for the solution for x is equal to 1/2. Because technically, we're losing that solution when we do this. Like, we're getting rid of it. So, we got to remind ourselves, you know. Remind ourselves to check for that. Okay, let's check for it. Okay, but now this isn't too bad. Because this is 2x plus 1 over 6 is equal to x minus 3. What is the gradient formula? Oh, that's just like a derivative in different directions. So this is 2x plus 1 equals 6x minus 18. Yeah, easy, right? So this is 19 is equal to 4x. So x is equal to 19 over 4. Did I do that right? I want to say I did. Okay, cool. But then we also got to check for if 1/2 would have worked. So if I did 1/2 over here, this would have been 4 minus 1 over a quarter, because that's a half squared. So that would have been equal to 4 minus 4, which is 0. And then on the bottom, that would have been 24 minus 24. Aha, this would have been 0 as well. You can't do 0 over 0. No. Yeah, can't do that. No. Makes math man sad. Yeah. So this one does not really work.
Oh, did you see that stupid thing where it's like someone proved that 0 over 0 was 2?
Yeah, that Terrence Howard math, dog. Like, people doing Terrence Howard math sometimes on the stream here with me. I'm just like, what? Excuse me? Stop.
0, 0 equals 2. No.
No, no, no.
Oh no.
Not again. Okay, cool. Good question there, Shantrix. Yay, nice. Good job. That was a fun one. No 0 over 0 until calculus. Yeah, no 0 over 0 until calculus.
No stateful problem.
Okay.
And then...
And then, let me see. We got a lot of good ones. Marco's posted some. Equity's got some good questions. Someone has an eigenvector question here. This is from Devil.
Can we just talk about hard drives for half an hour?
You want to talk about hard drives for half an hour? What? Who says they want to talk about hard drives for? Do you have some hard drives for us to see?
Look, let's just talk about hard drives for half an hour. Just fuck it.
Just fuck it. Let's just talk about hard drives.
It's easier, and I know more about hard drives than this shit.
I'm gonna tell ChatGPT to translate this this question. Okay, it has to do with eigenvectors. Okay. Oh, so is it like we gotta prove this? Is that what we're trying to show? Let x be the solution of a minus lambda ix equals vi. The vector x is then called the generator. Show that e to the gamma t x plus t a minus is the solution to this. Okay.
This hurts me.
Yeah, this is kind of like, it's not too bad, I don't think. So yeah, this is magnetic flux is phi, yeah, flux density, yeah, phi b or stuff, yeah. Okay, right, so eigenvalue stuff, that I believe is where you have like AV is equal to lambda V, right? Where this is the eigenvector, or eigenvalue, sorry. And then this right here is the eigenvector. What's up, Equity? How was AP? Did you take AP pre-calc? Is that what you took? And then this is... I saw you have some good questions here. We'll do yours afterwards. This is a matrix. Okay. But the way to solve... solve for eigenvalues is you always do this. You do the determinant of a minus lambda I, and then you set this equal to 0. I can help you with property circles. Submit a screenshot. There's a screenshot. For a website down there. Use that website. Okay. So in this case, well, wait. A was equal to the eigenvectors. Okay. So wait, what? So if A is equal to gamma alpha 0, right? Then A minus gamma I is the same thing as gamma minus gamma alpha 0. And then this is gamma minus gamma, right? And so then the determinant of this is just going to be gamma minus... Well, this is all 0 now. So it's just 0 minus alpha... Wait, it's just 0 minus 0. What? This is 0 minus 0 is equal to 0. So alpha can be like whatever. So you can have any eigenvalue just called alpha. What? A little confused what's going on here. What's lambda, gamma, and alpha in the real world application represent? What are they? Okay, yeah, cool. So, A here is like an operator, which can represent like a field or like different forces that are acting on things. Gamma represents like what a steady state to being in that field is. And then V, the vector here, talks about like where that solution points. Kind of where it comes from. Oh, wow. Thanks for... What's up, Sam? Good to see you, dude. Lambda is the eigenvalue because the bottom left is 0. Yeah. Yeah, I get it. I get what you're saying, yeah. What level of math is this? This is, I want to say linear algebra. But this is also differential equations. This is diffie-q. Okay.
This is mental.
This is mental. Okay. I guess we could like compute some derivatives is what we could do, right? So this, yeah, this right here, right? This whole thing right here is just equal to v1, right? Which is 1, 0. So this is actually interesting. So wait, e to the gamma t times x plus t, and then this is wait, let x be a solution. And then this is just v1, right? We need 2 eigenvectors, but we only have 1 eigen... Yeah, you can DM me. Yeah, math. Yes, exactly. Of like force representations. Exponential matrices. Yeah, what's up, Zach? Zach, maybe you can help me out with this one. Shout out to Zach, by the way. Zach is our resident awesome math smart person with higher level stuff. This is kind of like college level, which starts to like touch the boundaries of what I'm used to teaching. I mainly teach like middle school, high school. I teach some college, but calculus, I'll teach calculus all day. Diffie-q, this starts to get like a little weird. Yeah, exponential matrices. Dun, 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 dun. I guess. This gets very involved. I'm just trying to even see like how ChatGPT does this. Okay. Here's what they say. They say let us define like y of t. So they say x plus t times v1, right? Where v1 is equal to a minus lambda I times x. And that came from this, right? Okay. So, let's try to figure out... So, we want to figure out this. Y prime is equal to AY, right? So, if this is Y, let's figure out why Y prime is, okay? This is a product rule, right? Because I got things with T's in both of these things, right? So, this is going to be the derivative of the first thing with respect to T. So, that's just going to be... ddt of e to the gamma t, and then times x plus tv1 plus e to the gamma t, and then it's ddt of x plus tv1. Okay. This is easy. The derivative of e to the x is just e to the x dx, so whatever's up top here. So this is going to be lambda e to the gamma t, and then this is times x plus tv1, and then this is going to be plus e to the gamma t, and then the derivative of this let me think. Oh, okay. Well, assuming this, right, this doesn't depend on t, so this is just this. So then this is going to be this, tv1. Okay. Or just times v1, sorry. Just times v1. Because this is the only thing with t in it, right? Okay. So y prime. When we get to it, let me just get through this question first. This is equal to e to the gamma t, and then it's going to be times gamma x plus tv1 plus plus v1. Okay. And then I guess I could distribute it, but e to the gamma t, then that's gamma x plus tv1 plus v1. Gamma x, oh, plus gamma tv1 plus v1. You could do a Laplace transformation. Interesting. Can you do a Laplace transformation with vectors, though? Maybe you can. Okay. Oh, Zach says you can. What's up, Bum Bum? That's cool. Yeah, we're doing kind of like vector calc. Oh, you could do it component-wise. I guess so. Okay, let's compute now. So that's what this portion was, but now we got to compute what AY is. So AY, so that's equal to A e to the gamma t x plus tv1 okay, which is the same thing as e to the gamma t, and then that's going to be ax plus a tv1. But we said that v1 was equal to a minus lambda I times x. This is not grade 9. This is like sophomore, junior year of college. Yeah, if you're watching this in your high school, like, yeah, chill. We'll do some easier math in a second here. Okay, so let me like plug that in there, right? Maybe this will do some cool shit. Let's see. So e gamma t, and then that's going to be ax plus at, and then that's a minus gamma I times x. Okay. Did I receive it? If you sent me a DM, then yes, I probably got it. Yongyu. Give me a second. Oh. But the other thing we know, right, is that AV1 is equal to... right, AV1 is equal to lambda V1. Ooh. So wait a minute. I think I even want to change this. Because this is what we had for this, right? You see how I have nothing in terms of A's here? There's no A's, right? Ah, I see something really cool here. Yeah, wait. Let's just stop. Watch this. Yeah, so this is AX plus ATV1, right? But AX equals lambda x, right? So this is the same thing as lambda x. And then we're getting close. We're getting real close here. Gammas, lambdas, eigenvectors, yes. Yeah, good luck, future nostalgia. Okay. So I think I want to write... I think I want to write this out in terms of something.
No!
Oh wait, no. It's AV1 is equal to lambda V1. Yeah. I don't think I want to say that's AX yet. Okay, one sec. So from this, B1 equals AX minus lambda X? Okay. So AX equals V1 plus lambda X. Okay. So now we can plug that in for here. Watch this devil. Watch this devil. See this? I think I see what's happening. Okay. So this is V1 plus lambda X. And then this AV1, that's the same thing as plus lambda V1T. Okay. Oh, and look. That's equal to the same thing as this. Do you see that? Yeah, do you see that? That's really fucking cool, actually. So watch. This came here. And now, good. Yeah, you get like 1 equals 1. Congratulations, QED. Yeah, nice. Cool. Sweet. Sick. That was really tricky. Fuck. I'll admit, I had some guidance from ChatGPT to do that one. Because I don't know if I could have done that on my own. But I'm glad maybe hopefully this makes a little bit of sense to you, Chaotic. Yeah, that's really tricky. Fuck. Oh, okay, I need a little bit of a little breather break. Give me a second after that one. I want some soup.
Soup.
Okay, Zonghu says, hey, do my question next. Okay. Well, you're asking nicely, Zonghu. Let me see. You sent me a DM. Is your name Jaden, Zonghu, by the way? Oh my god, 200 people. Yeah, a lot of people watching.
We were up to 350.
Wow, 350? That's dope. If you stick around, I will do your question. Just, you know, chill, hang around, learn some math. Zhonghu, which one was yours, by the way? Is this your question? This like weird looking fucking pentagram? I needed this is my last question. Sure, I needed to know it, but also I need not only to solve it, but also have to do it in front of 200 people. You're welcome, dude. Okay. What's this weird dude? I hate circle theory. These things fucking make me so upset sometimes. Okay,
This will take
all right.
an hour.
No, I think we can get this. Fuck. Well, there apparently is a solution, so. Okay, Zhonghu says, given the following diagram, since when was math so entertaining? Yeah, since great teachers were born. Aw, Azrael, I appreciate that. I would also say it helps. We got memes and shit to do stuff.
They think it's fun now until they get the abuse from me.
Also, for everyone who's watching, yeah, just one quick. I'm not the only person that does this, by the way. We have a lot of really awesome math streamer friends that also do this. So if you go to our calendar on our nonprofit website, there's a whole schedule here, a Google Calendar that updates in real time when it wants to load. There we go. Of everybody else who does like math streams. So feel free to go check this out. Please go follow our friends. Like Zach tomorrow morning is going to be doing some. He's an awesome math PhD who does a lot with like infinite series. He knows a lot of the higher level math. So if you want to ask like really upper level questions, you should go by Zach's stream tomorrow morning. I'm better with middle school, high school, early college. He can get into like set theory and like all that other crazy shit. Yeah. Okay.
I do other things, but never mind.
Yes. Sensation does all the computer science and he teaches Japanese. We'll get
And
you back
English.
into and English.
Please come and learn English.
Please come and learn English. It's vital.
Most of you fucking need it.
Okay, given the following diagram, AD is a diameter of the circle. Okay, so this is a diameter. So this is free tutoring. Yes. Do I know anything about biology? Biology's a lot of just like looking shit up, but like whatever. I can't help with that. I do. I tutor a lot of free chemistry, and we were just doing physics earlier today. My PhD's in physics, so I love physics. So if you ever want to ask me physics questions, I'm more than happy to help. There's a lot of kids that need help with math too, so I do it as well.
I've got a copy of Grey's Anatomy behind me, if that's any help.
Yeah, Sensation's got a copy of Grey's Anatomy. He can go look up some cardiovascular systems or whatever for you.
What's the difference between the pharynx and the otopharynx?
I don't know, the larynx or something. I don't know. It's yeah. Okay, AD is a diameter. Given that FCE is equal to 24 degrees and EBD is given 18 degrees, find the value of X. Okay, so I believe there's a theorem here that if you have what is it? If you have like the same arc being covered, then you have to have the same interior angle. Is that right? Right? So for instance, konnichiwa, what's up, dude? So if this konnichiwa. If this
I hate it when Americans try and say that word.
Konnichiwa.
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 There's two N's in there, so it's konnichiwa.
Konnichiwa. Okay.
There we go. That's close enough.
There we go. Okay. So if you have points on a circle and they cover the same arc, then they have to cover the same angle. You want to be a marine biologist? That's cool, dude. I want to do that old scientist where they studied a bit of everything. Yeah, being a Renaissance man. Yeah, I like studying fucking everything. It's dope. Okay, so Zhonghu, or Zhongyu. So this must also be 24 degrees. Okay, because do you see how this covers the same arc length that this does, and both of these fuckers are on the circle. So this is also 24. Okay. Cool. Okay, then my last thing I think is that I think this has to make 90 degrees. Boys, am I right? Yes, Muhammad, I think you're right. Yeah. Yes. So I believe that if this is a diameter, right? And then this is a point. Why is this? But I'm pretty sure this has to be 90. Oh, you know why? Because this covers... Okay, watch. This is actually really fucking cool. This covers an arc length of 180 degrees. And whatever that angle is has to be half of that. Okay? So that tells me... Yes, and because every point in a circle with a diameter forms a rectangle. Yes. So this is 90 degrees. Okay? So now that I know that this is 24, then x plus 24 plus 18 must be equal to 90. So we get x plus 42 is equal to 90. So x is equal to 48 degrees. I think that's all that is. Yeah? Yeah, dude, it does look like a satanic ritual. Nice, cool, sweet. Yes, good job, guys. We did it. Not too bad. I'm getting better at the circle theorems.
The funny thing is, there is loads of like circle theorem stuff at higher GCSE, but I just kind of skipped over it entirely.
There are so many circle theorems. Yeah. He says I'll send you another one. Okay, but I have to go through everyone else's questions too. So if you just hang around, we'll get to it. Do you have any tips for the Regents? I don't know what the Regents exam is. Sensation, do you know what the Regents exam is?
That's new on me.
Okay. Is that like the New York exam for being smart? It is New York. Oh, okay. It is. It is a New York State exam. Okay. I'm not from New York. I live in Los Angeles. and I grew up in Texas. So I don't know exactly, but it looks like it's kind of like an upper level SAT, but with science, so it's like the ACT, I guess.
Yeah, I'm from the original New York, not the new one.
Yeah. So, I mean, how I can help you, so I don't have any tips specifically for that exam because I haven't taken it, but in general for any sort of like standardized test thing, the best way is just to do practice questions over and over again and just see what areas you need a little bit of reinforcement in. So, for instance, if you're going through a practice Regents exam and you find that you're getting perfect scores on all the physics, but, you know, the chem you get like half right, then that's a time for you to be like, okay, let me go do more specific chem questions. Or you could bring your chem questions here onto our stream because, again, if you submit a screenshot through the website, which a lot of students are doing now on YouTube, I'll go through that question on the stream, and then that can maybe help you see like where you have a little bit some deficiencies. Yeah. You hate the geometry questions? Yeah, I would hate the geometry questions too. That would be bad. I walked on the walls around York. It was cool. Isn't York like a beach town type thing?
No.
Yeah. Who's Jaden?
York was founded by the Romans.
York was founded by the Romans. Oh, okay. Let me see.
So, literally 2,000 years old.
Yeah. Yeah, what's up, Laz? Laz in the chat. What are you saying, dude? Not what I had in mind, but I was going to be a TF for mechanics and EM for academic year. Okay, cool. Equity, what's up? Is Equity still around? You asked your questions earlier today, and I should do them. How a condenser works? Condensers are really cool. Yeah, they are. Oh, Jaden. Oh, yeah, okay.
And I'll just say, Jongwen, Warboard All
right, here. Let me do some of Equity's questions because he asked earlier, and I haven't done his yet. And then Zhang, you can submit whatever. I'll help you out as well. Okay, so cool one. Okay. Says, solve this exactly. 6 sine squared minus 5 cosine theta minus 2 is equal to 0 on the interval x is from 0 to 2 theta. Include a diagram. Yes, Jaden, you can talk, but let's wait until it's your turn for the next question. And then yes, you can come up to the stream and say things. That's totally cool. So, one sec. Okay, this, I know that sine squared theta plus cosine squared theta is equal to 1. So, sine squared theta is equal to sine squared theta is equal to 1 minus cosine squared theta. So if I plug that into here, oh, good to see you, Bonbon. 6 times 1 minus cosine squared theta plus 5 cosine theta minus 2 is equal to 0. Let's distribute a little bit. So I get negative 6 cosine squared theta plus 5 cosine of theta, and then this is positive 6 minus 2. That's going to be plus 4 is equal to 0. This looks like a quadratic. Oh, did I fuck up? Minus 5 cosine theta? Because you're tight, yes. I did. Thank you, Fembox. Thank you, Fem. Fem's always here, like, making sure I don't make it. That would be a bad mistake. Let me get you your points there. Saves to Fem. Where's Jeff? Where's Jeff? We do, yes. So first thing I'm going to do, I'm going to multiply everything by -1 here, just to make it a little bit easier. So I'm going to do 6 cosine squared theta plus 5 cosine theta minus 4 is equal to 0. And then I'm going to say that u is equal to the cosine of theta. So u squared is equal to cosine squared theta. -8 and 3. Well, one sec. So that's going to be 6u squared plus 5u minus 4 equal to 0. Okay, good. I see what you're saying. So then this is a quadratic I can now solve with a little bit of factoring, okay? So I'm going to do 6 times -4, which equals to -24. And I need what multiplies the -24, but adds up to 5. And you're right. That's going to be -3 and 8. So I'm going to replace this with 6u squared minus 3u plus 8u minus 4 equals 0. So this got replaced with these two things. Okay. Now I need a factor. And I thought I was fast at math. Well, I've been doing this for a very long time. 3u. So then this is 2u minus 1. And here I'll pull out a 4. So plus 4, and then this is 2u minus 1. Cool. This becomes 3u plus 4 times 2u minus 1 equals 0. So now u is equal to negative 3/4, or u is equal to 1/2.
My man.
Okay. All right. But remember, u was equal to cosine of theta. So we need the cosine of theta to equal negative 3/4, or the cosine of theta is equal to positive 1/2. This is where it helps to draw a graph. Right? Little unit circle. So if cosine of theta is equal to 1/2, okay, that happens in two different places. Okay? So that's going to happen here. And then the other place that happens is here. I need the right angle. Yeah. So let's remember, right? So if this is 60 degrees, okay, then cosine, which is adjacent over hypotenuse, right? That's going to correspond to an adjacent of 1/2, a hypotenuse of 1, and then technically, I don't know, this is like square root of 3/2. So you're going to have 60 degrees, and then going all the way around again, which is 300 degrees. Did I do it wrong? I think it's pi over 3. Good, but the thing is from 0... Yeah, exactly. So I can't do the negative 60. So I'm going to say, cool. So theta is equal to pi over 3, or... what is that? Is that 5 pi over 3? I think that is, right? Because 6 pi over 3 would be going all the way around. Yeah, pi over 3 and 5 pi over 3. Okay, good. Cool. So that's for that. Okay. But then we have to do one for negative 3/4. Okay. So negative 3/4 is going to happen. Oh, that's weird. Oh, this is going to be the 3, 4, 5. So adjacent has to be negative 3. Or it's not, isn't it, right? Oh, this is just ugly. Okay. It's unfortunate. I wish this was nice. Okay. Because that means you're going to have negative 3 over here. And then you're going to have 4 over here. And then there's another place that happens. Which is going to be here. Oh, if I can move this today. There. You got to put it in the calc. Yeah, I wish this was 3/5, because then it would be the 3, 4, 5, but it's not. So, yeah. So then what I like to do is to figure out, like, this angle here. Theta. That's going to equal to the arc cosine. I'm going to say adjacent over hypotenuse 3 over 4. Nice. I'm doing the positive one here just because... I'll show you. It's the reference angle is what it is. And then we got to make sure this is in radian mode. Good. So arc cosine of 3 over 4. So that's going to give us 0.723. But that's what this angle is, okay? So if I want the whole thing, okay? So from here to here, I have to do pi minus this. So pi minus 0.723. That's like the first solution. And then the next one is going to be pi plus that number. Okay. So then this solution here is equal to pi plus 0.723. It's a pair function. There's no difference between negative and positive. You're right. You're right. You're totally right that there is there. I just tell kids to just make it positive because otherwise it gets kind of weird. Oh, I have a mistake on this part. Where did I fuck up? Oh no. What'd I do? What did I screw up on, Fembox? One sec. Where's he saying I messed up? I think we're okay, right? Cosines adjacent over hypotenuse? Oh. I don't know why I wrote this as 3/4. Oh, that's so wrong. Oh my god, no. Oh god damn. Yeah. Sorry. Okay. This was wrong the whole time. This is equal to negative 4/3. Okay. Oh no. Okay, I slipped. My bad. Thank you for catching me, chat. Okay. So this actually doesn't create any solution. Because cosine of theta can only go from -1 to 1. So there is no solution. Yeah, equity. So there's no solution for this one. Because, yeah, you can't have it being equal to 4/3. But if it was equal to 3/4, that's how you would do it. Yeah, oh, cool. Okay, cool. Nice. Thanks, chat, for catching me on that. Yeah. I make mistakes. I'm human. Okay. You had some other fun ones in here, which I want to get to. Jaden says mine. Jaden, we just did yours though. I'll get to it, but I gotta make sure we have time for everyone else who's asking questions. Yeah. Yes. So there's two solutions. Right, so in this question there were two solutions. So don't worry about this. This is all wrong. But there was this, pi over 3 and 5 pi over 3. Because I think the solution was between 0 and 2 pi. So yeah, you could have had that theta was equal to pi over 3 or 5 pi over 3. Yeah, nice. Okay, let's see, more trig. Coming on up. Ooh, what is going on here? Sine of pi over 2 minus x cotangent of pi over 2 plus x. Okay. I don't like cotangent, but I know cotangent's cosine over sine. So this is sine of pi over 2 minus x times, and this is going to be cosine of pi over 2 plus x over the sine of pi over 2 plus x. Okay. Sine of pi over 2 minus x is the same thing as cosine of x. Right? This is the same thing as the cosine of x. And then what do I want to do with this, though? I feel like I want to do something with this. What's the identity on these? Well, here are the ones that they get. Sine of pi over 2 plus x is just a phase shift by pi over 2, he says. Well, let me think how that works. So, okay. If I have some angle, right, equal to x, and then I move it by pi, does that always switch it from positive to negative? I believe it does, right? Right? If this is like, for instance, like 50 degrees, and then I add 180, then I'm over here, right? I always gotta be careful, like, what quadrant we're moving things in. Oh, wait, but we're not adding 180, we're adding 90, right? So, I don't know, if this is like 50 degrees, and then I add 90, But see, in this case, it keeps it positive, but in this case, it makes it negative. Yeah, the issue is that I believe this changes, right? Based on what the angle is. Someone says cosine of x plus pi over 2 is equal to negative sine of x. Where does that come from? Okay. Well, there's a lot of it's being flung around here. Yeah, what is it? Which is it? Is it? I'm tempted to use one of these identities. I know I want to get eventually. I just want to get to sine, right? I'm tempted to use like these because these are for like pi over 2 minus theta. Yeah, exactly. Let's use this one. So if I do sine of pi over 2 plus x, that's the same thing as sine of pi over 2, right? Which is equal to 1, right? This is equal to 1. Cosine of x. And then this is plus the cosine of pi over 2. But cosine of pi over 2 is 0. So I don't care. Okay, so sine of pi over 2 plus x is just equal to cosine of x. That's cool. So this is equal to cosine of x. Okay, so I get cosine of x over cosine of x. So that's eventually going to go... And then I'm pretty sure cosine of pi over 2 plus x is just negative sine of x. So let's just do it this way. So pi over 2 plus x. So that's cosine of pi over 2, which is 0. And then that's going to be minus the sine of pi over 2, which is just 1. And then sine of x. Okay, cool. So cosine of pi over 2 plus x is just equal to negative sine of x. Very cool. So then this is just equal to negative sine of x. And then we have cosine of x times negative sine of x over the cosine of x. Cancel, cancel. And we're just left with negative sine of x, which equals negative sine of x. Nice. Cool, that's a fun one. So yeah, you could just write it as the sum in different identities. Totally could. That totally works as well.
Well done.
My soup is all cold now.
Soup. Is it soup if it has stuff in it? That's the question.
It's like ramen. I made like fancy ramen. Okay. Here, Mohammed, you have a question. What's your question, dude? And then let me see who else submitted some. Wow. Bro, what is this question? And Jaden, did you DM me? You did DM me. Here, I'll check those. Yes. How do a condenser? Wait, a condensator in the electricity works? What's a like, I know how a condenser works in like thermodynamics. Condensator? Sator.
It just says condenser.
Oh, they call it, that's a capacitor. They call it a capacitor. Oh, that's so cool. Is that French?
Yeah.
Oh, that's really cool. Yeah, I can explain really quickly how that works. And then Jaden, we'll do this one for you. Also, like, who someone asked me these, which is pretty dope. Someone's talking about like antennas and stuff. This is really cool. I don't know if I know how to do this though. This is like some high-end engineering work. Oh, thank you, Zach. Yes. Zach has a really good point about like sine and cosine. Yeah, sine and cosine are off by a factor of pi over 2. Oh, so you're so right. Oh, that's actually really cool. Sorry, I'm going to show that real quick. Thank you, Zach. I appreciate that. Yeah, Zach was making a really cool description here. So, for instance, sine of x. Well, if I could draw things correctly. This is y is equal to sine of x. And then cosine of x kind of looks like the same thing, it's just like shifted a little bit. That's right, this is cosine of x. And so cosine of x is equal to sine of x plus pi over 2. Is that kind of what we think about that, right? Because, yeah, you'd have to, like, pull it back. Right, and that's where this came from. Drawing symmetry is hard. Yeah, that's cool. Okay. Yes, because this is shifted by... I like that. That's a much more intuitive way than the sum or difference. Because this is pi over 2. And this is also why, for instance, sine of x is just equal to cosine of x minus pi over 2, because it shifts it forward. And you're right. Do I do any topology or theoretical geometry? I don't. But Zach in our chat, e to the 2I pi, who's there in Twitch, he does. He probably does that stuff, or he knows people that do. So I recommend, yeah, if you want to check out the Twitch and then follow him, he has streams 3 times a week. He can help you out with that. I do very little topology. I just think of that as just being like really advanced math. So you're my advanced math guy, Zach. But maybe Zach knows somebody who does it. Do you think, does Penn Center do that? Who does topology in our math compadre group of things? He says I know people. He does know people. Zach does know people. Okay. So one sec. Let me explain the capacitor, and then Jaden will do your question. And then you can talk if you want. Okay. Just say yes, and he'll do it. Yeah. Just tell Penn Center he's got to do it, man. It is very challenging. Okay. So a capacitor. Okay. Which looks like this in like a circuit. This is a capacitor. It works by having plates that have like a bunch of charge on it. And then there's another side of the plate that has like a bunch of negative charge on it. But they're not allowed to touch each other. Okay? There's a gap. There's a gap here. Okay? So what that does is, because you have differences in charges here, this creates an electric field. And then because there's an electric field separated by a distance d, this is going to lead to a potential. And so capacitors kind of work like batteries, because you can store up potential like voltage by putting a bunch of different charge on either side here. The only difference is it doesn't hold charge very well. Oh, Xiphon SVC sometimes does topology. Okay, cool. Yeah, in the chat there, Abo. There are some other streamers he talks about. Right, yes. So electric field, yeah, comes from here. The cool thing about capacitors is they can be used as filters. Because what capacitors can do, they can absorb so they can absorb spikes or provide extra voltage for dips in a circuit. So a lot of times these capacitors, they act like kind of like a filter. So anytime you got like big spikes in voltage or you get sudden drops in voltage, the capacitor will either like absorb that or it will provide the missing voltage that's needed temporarily. So we use them a lot in, like, for instance, like RF circuits. So RF circuits or sorry, RCF circuits. And they provide a way for things to like oscillate and stuff. They're really cool. Oh, sorry, where yeah, here, one sec. Let me pull in the here. This is from the Twitch chat. What courses did I take in high school? I took AP Calculus. But Abo, there you go. He says this guy Xiphon SVC sometimes does topology. He's another guy on like Twitch. I took BC.
Nice.
So yeah, capacitors are cool. This, if you eventually want to do other like questions with this, it's good with for instance, like this is the big thing, Q equals VC. So we could say like the charge stored is proportional to the voltage times what we call like the capacitance. And this actually gets into what's called like differential equations, because eventually you're going to learn about other things which are like called inductors. And these things resist changes in current, which is also known as di dt, which is like d squared q dt squared. Capacitors resist changes in voltage. And they're related by this, where like so here, this is what we call like, this is like back voltage. And then this is V is equal to Q over C. So here you have like, for instance, like Q double prime. This is the second derivative of charge. Here you have Q0, the zeroth derivative. And this ends up, when you do like loop law equations, it creates differential equations on how to like solve circuits. Yes, RLC circuits being damped harmonic oscillators is so cool. It comes from this because, for instance, if we remember, if you have like a mass connected to a spring, you get like F is equal to KX, right? Which is equal to also to MA, and acceleration is like the second derivative of position with respect to T. So this similar situation happens here, where you get X equal, so K over MX is equal to D squared X dt squared. And then this is called like omega naught squared. And then with capacitors and inductors, you get the same thing, where you get like and there's a resistor in there too, usually. So there's like, it's like 1 over RC Q is equal to, or here, no, it's, yeah, well, okay, not put the resistance, is equal to 1 over C Q is equal to D squared Q dt squared. And then this is times L. So you get 1 over LC Q equals D squared Q dt squared. And this is like omega naught for how a circuit will oscillate with an inductor and a capacitor. Yeah. Sorry, it's negative KX. Yeah, there you go. Sorry. It's a negative in there. But yeah. It's very cool. Yeah. Yes, that's an undamped spring. So it's actually cool. When you start incorporating dampening into the spring, that's the same thing as resistance in an RLC circuit. Yeah. Okay, but yeah, I hope that like gives you a little bit, Muhammad, about like what goes on. This is why circuits are like super cool. And I think it's like super dope that electronics stuff mimics physical behavior with like springs and pendulums. Like these things with like batteries and like resistors and electrical components have analogs in like the physical world of just like things. It's super cool. You're like, oh, we're in the Matrix. Because like there's got to be a reason why everything seems to be following like the same like operating system. It's all following the same code. Okay.
Don't take the red pill or the blue pill. Just take loads of pills.
Just take all the pills. You understand it now? Cool, man. This is the type of shit we learned in 12th grade in India. That's cool. Yeah, we learn all types of stuff. Okay, Jaden. Let's see. Which one did you need help checking on, Jaden? Here, you can come up and talk if you want. Let me invite him to speak if he wants to speak. Although, be careful about what you say because we're live on Twitch and YouTube. So, what's up, Jaden? Can I hear him? Is this mic working? Got him up. Okay, let's see. In the following diagram, O is the center of DEF. Find the angle of X. Give a reason for each step. Yeah, this is cool. So, I agree with you here. I don't hear your mic, by the way, Jaden, yet, so let me know when you get that fixed.
Nope.
Oh, there he is. One sec. You gotta boost your gain up. Try boosting whatever your gain is on your mic. Oh, I hear him a little bit. Has anyone done graphing using the z-axis as an y-axis? I don't think I have the meat, but that's cool. Welcome to the stream, by the way. Okay. Let's see. This is 109 degrees. And remember what we said is that if you have a point on the circle, it's always going to carve out twice that arc length. So this is going to be 218 degrees. What's up, Jaden?
O is not inside there.
What's up?
It's not inside the circle.
Well, this is inside the circle, right? Isn't this like on the circle, dog?
But
No?
why you get 360 first?
Okay, well, one sec. We'll get to that. So, first thing I'm doing here, Jaden, is I know if this connects to points D and F here, that this, so the amount of arc, like angle that this picks up is twice what this is. So this is 218 degrees. This is 109 times 2. Okay. And then if I know this is 218, then the rest of this has to add it up to 360. Okay? So we can call this X. So then we know this plus X has to be equal to 360. So X is equal to 360 minus 218, which would equal to 142 degrees, which I think is what you got. So that was correct. And that is what you wrote down, Jaden. You did write this down, but you tell me.
So this one is twice the angle, and then you need to 360 minus 30.
Yes. Yes. If this is 109, Jaden, you double it to get 218, which is what the blue is, right? And then 360 minus that will get me what this angle is. Arc angle is the green, and since that is about the center, so that angle is about the center, whatever this angle is marked here is the same angle here.
Oh, so
right?
I just can't do 109 times 2.
Well, 109 times 2 gets you this, okay? Because if your endpoint is on the circumference, and then it has two lines connecting here, this arc angle is twice this. Okay?
Okay.
But if if your center point here is, if the point where you're making your arc is at the center, then this is equal to the same thing as this.
So it's like, so it's like circle is 360. Then you
Yes.
get the inside.
Yes. Yes.
Oh,
The total angle inside a circle is 360, and on the outside, the total going around is also 360.
that's not a cyclic quadrilateral, right?
Sorry, what?
It's not a cyclic quadrilateral, right?
It's not a cyclic quadrilateral. I don't know what a cyclic quadrilateral is.
Does the four sides touching the circumference?
Oh, the four sides touching the circumference. Okay, that's something different. That's probably what's happening here, right? So here you got a bunch of weird shit going on, right? This is like 1, 2, 3. Well, I don't know what's happening here. Fenvox says cyclic quadrilateral. Yes. Okay.
So it's not the same as question number 4, right?
Question number 5 is different. Let's look at this. One sec. It says, O is the center of a circle. Giving the reasons first, try to work out the values of X and Y. Okay. Ooh, this is very interesting. So this is the center. Okay. Ooh. And we know this is 104 degrees. So Hamilton says for a cyclic quadrilateral, all the corners have to be on the circumference. Okay. So ADCB here, Jaden, this is a cyclic quadrilateral because all of the corners are on the circumference. I'm not talking about
So
O.
opposite. So it's opposite angle, 180 minus 104, right?
Okay, interesting. But whoa. That 104 though has one of its vertexes in the center of the center, right? So that doesn't necessarily tell me about the 180 thing. Let me get this one sec. Okay. Here's something. Here's something. Let me. So this is such a such a low resolution image. I'm really trying to it's very blurry, but I'm trying. Okay. Let me redraw some stuff here so that I'm not losing my mind trying to. Okay. There we go. Okay. That. This right here is 104 degrees. Okay. And then this right here is equal to X. And then there's another line here I'm going to draw, which just does this.
Oh, so Y is not equal to X?
Y, I don't think Y is equal to X. And let me show you why. Okay, so Y is equal to this, I believe, yeah? Okay. All right, first off. Okay, this right here, Jaden, this is the center of a circle, yes? So if this is the center of the circle, then the arc that spans out, so this arc here, all this purple, is going to be equal to 104 degrees as well. Okay, right? Because the arc spanned out by the center of something is always equal to the same number.
This book is finished, so I need to quick revision on that.
Okay. Now watch what happens here, Jaden. This arc of 104 degrees is also spanned by this. Do you see how this also spans the same 104 degrees?
Yes.
But that point is on their circumference. So that is going to be half of this angle. That's why this is 104 divided by 2, which is equal to 52 degrees.
Oh, in this X.
Yes, X is equal to 52 degrees then. Because X spans an arch of 104, but X is located on their circumference. Okay?
Still don't understand.
Okay, well look, okay. If you have do we understand this? That this is an arch, and that this arch has a certain length to it?
Yeah.
Okay.
Yeah.
If the arch is connected by 2 points that go to the center, then the angle here is also equal to the same angle of the arch. Okay?
Okay.
So, for instance, right? If I have a point here in the center, and let's say here it spans an angle of, let's say this is 60 degrees, okay?
Yeah.
Then the angle of the arch, so this, is also equal to 60 degrees. Okay?
So angle of the, what about this? It's like a sector, right?
Good, it's like the sector length. The sector length in degrees, yes. Okay. But now watch this.
So
If I connect those same 2 points, right? You see how this is the same sector? But
then
now,
divide by 2.
now it divides by 2. This is now 30 degrees. Okay?
So, yes.
So look here, right?
Because next month is my midterm examination, so I need to quick revise.
Oh, you're good. You're good. I mean, I'm happy to teach this to you. I hate this shit too. Because it's a bunch of random theories. Okay? But the main thing you should see here, Jaden, right, is that because this is the center, right? That means that if this spans 104 degrees, that this arch here, this sector is 104 degrees.
So it's like and you scroll down a bit. So it's like 30 and it's reversing, right?
Sorry, say it again.
It's like so it's 2x and x is reverse, right?
Good.
Is it reverse or?
Yeah. So remember that the angle here is half of the arch if that angle is made on their circumference. If the angle is made on the center, they're the same. Okay? So here, the arch was made from an angle in the center. That's why, since we know this is 104, this is also 104. Here, that angle is made on their circumference. So whatever this is, the 104 is twice that. So 104 is equal to 2x. And that tells me right away that x is equal to 52.
So if I do 180 minus 104, it also can, right?
Well, I don't know about the 180 rule. Let's get to that in a second. Let's just agree that x equals 52 degrees. Are we cool with that so far?
Okay.
Okay. All right. I got to see what you're talking about with the 180 thing. I think what you're saying is that, are you saying that this plus this has to be 180 because they're opposites?
No, but 180. No, exactly. Based on my theory, I can use 180 minus 104 cyclic. Yeah, such a lot. Yeah.
I got it. I got you, bro. One sec. Yeah, there are so many theorems here, unfortunately. No, that's not it. Sorry. Dude, what? I copied this.
If I use 180 minus 104.
Okay, here we go. Opposite angles add up to 180 degrees. Okay, cool. Yeah, I agree with this. Okay. So, you're talking about, now I have a new cyclic quadrilateral, right? Which has been made from here, right?
Yes.
Okay.
Yeah.
Because these are all on the circumference, yeah?
Yeah.
And this one is opposite to this one, right? See how these are opposite?
No, it's not opposite. That 104 and y are opposite, right?
No. I think angle Y here is opposite to angle X. Don't worry about the 104. We're not worrying about the 104 right now. So, so look here. So this is a quadrilateral, right? Right, Jaden?
Yep.
That has 4 points on it. Yeah?
Yeah.
And there are angles to each of them, okay? I'm going to say that this angle here is opposite to this angle here. Yeah?
Oh, yeah.
Okay, so those add up to 180. And then I'm going to say that this angle here, right, which makes with this corner, is opposite to this angle here. These are opposite. This one can't be opposite to this one. That doesn't make any sense, right? Because this one and this one are opposites. So this one is opposite to this one. So that tells me that x plus y must be equal to 180. And x is equal to 52. So
52?
x was 52. We found that out earlier, right? We did that here.
Oh yeah. Oh yeah.
So 52 plus y is equal to 180. So that tells me y is equal to 180 minus 52, which is 128 degrees.
No, but go there. But it's 316 minus 104 divided by 2 because
Wait, what?
Yeah.
360 divided by
I'm
140 over 2? Yeah, okay, so this was okay with the x. I agreed with x being 52 degrees. I mean, this is kind of weird why this is. I mean, whatever. I think the way I explained it is better. But then you still need y. You still need y though.
Because my school teacher told me I need to get the inside to get the outside. It's half.
Yeah, okay. So what your teacher's doing, they're saying, yeah, wait, they're saying angle at the center is double the angle of the circumference. Wait. Okay, so they're saying, oh, I see what they're saying. They're saying this angle right here, Jaden, is equal to 360 minus 104, right? Because this is 104, so this is 360 minus 104. So, yes, 360 times 104, that's the same thing as 256, okay? I need this smaller, sorry. This is 256, yes? And then this, right? Do you see how that spans out the same arch of 256?
Yep.
Okay. So then this must be half of that 256, which is why it's 128, which is the same answer we got here. Hey, I think you were a TA in my class. Well, I don't think I was a TA in your class.
Also the
I haven't
same,
been
right?
in a while. What's up?
It's also the same, right?
Yeah, this is the same. Yeah, you're still going to get y is equal to 128. And then this, it's just because you know this is 104, you know this is 104, and then half of this gets you the 52.
So every circle is 104.
Every circle is 104? No.
No, so one part only 104.
So, because this angle here, sorry, because this angle right here was 104, this thing here is also 104 because they're both at the center.
So one part is only 104.
Yeah. So this part's 104,
So-
which means that this is half of the 104 because it's connected on the edge.
Okay.
Wow, Pen, thanks for the sub, dude. Good to see you, Pen.
What if not connecting on the edge?
Connecting on the what?
What if not is on the edge of the circle?
X is on the edge of the circle. Yeah, this is that arc.
What if not on the edge?
I think this is on the edge.
What if it is not?
What if it's not? Or then you're fucked. You can't do it.
So
You're-
I need to
you-
get
Your teacher's always going to put things on the edge, right? Do you see how these? Do you see how these? Jaden, look, these are also always on the edge, or they're at the center. That's the rule.
okay.
They're either going to be on the edge or the center.
So it's
right?
like so is like I can see the center is not 90, right?
Right here. Yeah, this is not 90.
Yep. How
Here, let
come
me-
it's not 90?
Well, I'll show you. One sec. So something is only 90 if it goes through the diameter. The diameter means it needs to go through the center and it needs to go to both sides in order for it to. No, that's here. This is what they gave you. Watch. They gave you
Yeah.
this, Jaden. They gave you this as being 54
Yeah.
degrees. We agree that's 54 degrees?
Uh-huh.
Okay.
Yeah.
So then what is the length of this arch?
I guess.
You can guess. What do you think it is?
So it's like 100.
It's
So it's
108.
Like,
Because the
108?
length of the arch is double what the angle is here if it's made on the edge. See? Does that make sense?
I have to go to school soon. Here's my last question.
Okay. You gotta go to school soon? Are you calling us from China? Where are you from, dude?
Malaysia, bro.
Malaysia! I love when we get students from all over the fucking place, dude. Malaysia, that's cool, Jaden.
Yeah.
Okay. So this is 54, right, Jaden? So this is 108. Because if something is connected on the edge, the length of the sector or the arch is twice what the angle is. Okay?
Wait. Okay. If I have homework, I'll call you to teach me.
You can always come by the streams,
This one.
Jaden. Don't worry. Yeah, if I'm here, you can
Okay.
always come by the streams. I don't think you can call me
Okay.
outside of the streams because I'm busy. I teach physics at UCLA, so like I don't have a lot of time.
Okay.
But I donate my time here already.
Okay.
Okay. Do you have to go?
Not yet. Just
Okay.
my last question.
So here, let's help you with this, okay? This is 108, all right? Now look what happens. This, right? Do you see how this right here maps out the same sector? But the angle it makes is connected at the center.
But this is not. But how do you know it's the sector?
How do I know that this is the sector from here? Because if I look
From
at the
the
line
radius?
from here to here, you see how this is the
It's
same,
the radius.
and it is the radius. That is the radius too, for sure.
If the
So-
radius connect to each other, but
Yes.
if the radius connect
Oh,
to each other,
yeah.
then
No, you're right. I assume this is the center. I assume when they put O, they mean the origin. That should be the center. We really hope that's the center. Otherwise, we can't really do this question. Okay. So because this is the center, this angle is the same as this angle, which is why you wrote down this was equal to 108.
Okay.
Okay? And then by the same theorem, right, with this and this, okay, do you see how this also maps the same sector, but it's connected on the edge?
But is this a combined sector or?
This thing here, right? So PT and PR maps out the same sector that QT and QR mapped out. So if they map out the same sector and they're both located on the edge, then that angle on the edge has to also be the same.
So,
So
it's
that's-
108 divided by 2.
Good.
Get 54 again.
This is also 54. Or whatever. Yes, 54.
Because I see the same segment.
Good. The same sector. Yes. Okay. So then the last part of this, okay, is figuring out
It says,
this angle, right?
They say find angle TPR, TOR, and TSR.
Okay, well, we found everything, right? We found out this is 108. We found out this is 54. We found out this is 54. The last thing we have to figure out is this, TSR, okay?
So it's
So watch what happens here. Okay. So this, right, TSR, do you see how this maps out this sector?
yes.
Okay. This sector is equal to 360 minus the 108. Because
360,
this
but-
amount is 108. So to go all the way around would be 360. So 360 minus 108 is what maps out this.
So it's okay.
Okay. So that angle is 252. Okay.
252.
That's what this is. This is 252 degrees of sector. Okay. But
Okay.
this, again, is measuring that sector from the edge. So it's going to be half that. So you're going to do divide
it's
by
like-
2. And that's going to get you 126. That's why this angle here is 126 degrees.
So if the rules tell us that the circle theorems, right, and then if it's isosceles, then you need to divide by 2, right?
Yeah.
And then what if it's the same length segment?
Then it's the same angle.
then it's the same angle. How
Yep,
do you know
exactly.
whether it's how do you know whether it's same or not?
If two, sorry, I gotta show something on the page. If two sectors are the same, right? Do you see how these map
Yeah.
out the same start to finish?
Huh?
Okay. Then the angles they make are also the same. So this angle is
it's like
equal to this angle.
For example, if I want to find 54, what is x? Then it's also 54, right?
Yes. This is x, this is 54, this is 54, because they both map out the same amount of sector. Yeah?
So, and then the sector, then 2x, that one I don't understand. And then
Okay, which one?
2x and then x. The
So then this right here, this is 108 because
Uh-huh.
it's not being measured on the edge. It's being measured on the center. And if it's being measured on the center, now this angle is the same as the angle of this sector, and the angle of this sector is twice what this is. So that's why this was 108. Because it's twice what the 54 is.
okay, so I'll try to send you some of these questions and then
Okay.
maybe
Does that help? Does that help you out? Does that make more sense to you at least? Yeah. Does this make a little bit more sense? I hope it does.
Yes.
Okay, nice.
I think I have a little bit more time.
Okay. Good luck at school in Malaysia. Have fun, dude.
I think I have a little bit more time.
Oh, okay. Well, let me answer. We have a queue of questions. Let me answer some of the other questions in the chat,
Okay.
and then
Okay.
and then I can come back to this if we have time. Otherwise, we stream tomorrow as well. We'll be on as well.
Oh,
Here, Josh needs help with how to submit questions. Can you tell him? Shot.
So yeah,
So
but
help
just
screen.
know.
You're good.
so it's like always remember it's twice the circumference, right?
Yeah.
Okay. Okay. Bye.
All right. Bye, Jaden.
Nice.
Oh wow, that's cool. Helping someone all the way from Malaysia. I feel like if I spoke Malay, it might be easier. His English was decent though. I can just tell there's some like translational difficulties sometimes. But math is all the same language. Okay. Let me see. What else we got? Josh was here asking a question, but and then Zetra Scythe. Let me see. There we go, Josh. Okay, cool. Here. Josh asking a question. I'll do yours, Josh, because you're right here. And then maybe Swarden or Anton. What's up, Pen? Good to see you, dude. Thanks for coming by. Let me shut you up, Pen. We had someone was asking about topological abilities today, yeah. Vito says, what classes do you teach at UCLA? I teach Physics 5A. Oh, who's Master Chief coming out? There's Master Chief. What's up, Yomzid? Okay. Alright, let's see. Ooh, is this physics? I don't know if this is physics. This looks like engineering to me.
I only got baby voice coming on. Who put baby voice on? Zach put baby voice on. Okay. Given the rod supported by thrust bearing at what the fuck? Excuse me? This is not physics, this is engineering. Because also they're putting things in pounds and feet. You can't do pounds and feet in physics. Okay. Find the reactions at the thrust bearing A.
And cable BC.
Nice.
Cable, the rod supported by thrust bearing A and BC is subjected to an 80-pound force. Is the 80-pound force have to happen here? Josh?
See, here's the part I don't understand. Back in the days, it was pounds per square inch.
Yeah, this is definitely not pounds per square inch. Well, that's PSI. Yeah, that's pressure. This is
pounds per feet, so it's still pounds per square inch.
like the rod is subject. So is the 80-pound force happening right here? Is that what's happening? Okay. And then there's a bearing BC and there's a bearing at A. Use torques about the y-axis, I think as well. Yeah, also I don't know the mass of this pipe. Do we assume the pipe is massless? Like what? Okay. All right. Well, there have to be two forces here, right? I gotta have a force here and call this like F. Let's see, if this is the x direction, this is the y direction, we're gonna call this the z hat direction. Call it z hat. Okay. So just looking at sum of forces in the z direction, we have FAZ pointing up plus I'm gonna say FBZ, which is just this. I think you need to know the bearing can't take any moment. So I don't know what that means. This is where like this is not physics anymore. This is engineering. I don't know what the fuck a bearing does in physics. I mean, I know what a bearing does in like real life. Like I know it's for like helping things to you know, rotate nicely, but I don't know exactly what that has to do with engineering. You need to declare the freedoms of movement. Dude, this is where engineering starts getting so wacky, dude. What? What are these weird-ass terms they're using for things? Freedom of movement? Oh, my God. Ugh. Okay.
I think it's literally just a lever that moves.
I think there's some...
I think the handle is BD. And it just turns.
Well...
Hello.
What's up, Ethan? Good to see you, dude. B can only take forces in the x-axis. I agree with that. I agree B can only apply upwards. What does this have to do with A, though? A can take them in Z and X, but it can't take them in Y. Okay, I think I understand that. Because we're saying that this thing can only move around this way and this way. So it can't take any force in the Y direction. Oh, cool. Whatever. Well, I only have forces in the Z direction right now, right? I only have FA pointing up here. I only have FB pointing up here, and I only have the 80 pounds moving down. Okay, so now I want to talk about torques. But because we only have Z components in the force in X is 0. Yeah, exactly. Right. Degrees of freedom versus degrees of control will decide between statically indeterminate and statically determinate. Yeah, this is where statics, dude. This is just weird shit, dude. What? Y'all engineers all coming up with these like cute little names for things where I'm just like, bro, what? Like, so the force is 0, the torque is 0. Like, which one is it? Yeah, and then they talk about the moments. I call it the sum of the torques. Like, I could give a fuck about what the moment is. It's the torques. So if this thing has a force downwards at this point, that's going to create a torque on this, right? Yeah, torque is moment. Yeah, exactly. Yeah, I don't know why they come up with these cute little names for things. So the torque is equal to, it's like R perp F, okay? So I got to think about what the torque is about point A for this. Okay, so R perp in that case is equal to this, isn't it? What's up, Josh? Ethan, give me a second. What's up, Josh?
I'm doing pretty good. I'm confused.
Yeah, what's up?
So it's supposed to be all about using moment or like torque or whatever.
Mm-hmm.
I just don't know how to apply it here.
Okay. So, torque, in the physics sense, is always equal to the perpendicular distance from somewhere times the force that's being applied. So in this case, the force from the 80 pounds is being applied downwards here, okay? And that has a perpendicular distance to it. Torque about point A sums to 0 on the y-axis. Yeah. All right, we'll get to that. So, okay. R cross F. Yes. Okay. Can anyone fill me in why this guy is solving a statics problem? It's because someone asked one. It's okay. Okay.
Sorry, do you only do physics problems?
No, I mainly do physics. I do everything.
Okay. I'm a math major. I'm being forced to take this course kind of against my will. I don't know why. I have also some math questions that I have that I'm a little bit confused on as well.
I could probably help you with the math more, but let me finish this one. That is cruel and unusual that they're making you take statics as a math major.
Yeah,
because
I know.
Even as a physics major, I would loathe this shit, dude. Like this, it's so like no.
They make me take a couple basic sciences. I also had to take a chemistry course. That was not fun.
Chemistry's
that
okay.
was really not fun.
Chemistry's okay. I'm okay with chemistry, but this this gets a little wacky. So, but here, let me just do this one real quick for you, okay? So, because it is. Wait, how much math have you done? Have you done vector calc at least?
Yeah.
Okay,
so
cool.
I'm working on graph theory stuff right now.
Perfect. So here, I'm going to show you real quickly just what like the torque definition is without all this fucking other whatever shit they're doing. Okay. Torque is equal to R cross F. That's what it is. Okay. It's the vector R crossed with the vector F. This is the math way to do it. So if we consider about point A, then the R vector points from here to here. Okay.
Okay.
And then so that has some components in the x hat direction and in the y hat direction. Okay. But then F, the 80 pounds being pushed down, is completely in the negative z direction.
Yeah.
Okay. Okay.
Okay.
All right. So if I wanted to do R cross F, right? We know from vector calc that's the magnitude of R times the magnitude of F times the sine of the angle in between the two. Okay. For a cross product, and the angle between R and F, that's 90 degrees because R is in the XY plane and F is in the Z direction. Okay. Cool. So R, as someone said up in the chat here, this is a Pythagorean thing, right? Because you have 6 this way and 1.5 this way. So you have the square root of 6 squared plus 1.5 squared. So this is equal to the magnitude of R. And then F, the magnitude of F is just equal to 80, okay? And so this is equal to the torque from, I would say, the 80 pound thing, okay?
Yeah.
Okay, now
I'm gonna interject real quick here. I think that because it's a bearing, right?
Yeah.
We can ignore the entire all the moment that is off axis, like off the plane. So we only need to worry about the 1.5. So we can just do. Oh, we don't need to worry about the 6. Okay. Yeah, because that's in like the other direction. So we don't need to worry about the torque that's happening, going like the torque that would be pulling it down. We gotta worry about the torque that's like moving it in the direction that it can actually move. I see the left and right thing. I see what you're saying. Yeah. Okay. So we just 1.5 times 80.
Good. Okay, that's totally fine too. Thanks. Yeah. Okay, Zach. Yeah. Okay. Cool. All right. So let's get rid of that. I see, because you're rejecting any component along this direction. Okay, that's fine.
Yeah, I think what we do is I saw it in the lecture. I'm just like a little bit confused on actually solving it. They say
they do 1.580 here, right? And then are they going to do BC times 3?
I guess so.
And then so they're going to do
cancel out.
Yes, minus FBZ times 3, and then this has to all equal to 0. And the reason being, right, is that the torques are going to be opposite, because this is a force down, and this is a force up. So the torques are opposite.
And if the distance is double, that just means that the force is just twice as much at BC, right?
Sure, great, yeah. So that tells you right away that FBZ is equal to 40, right?
Yeah.
40 newtons, okay. So then you can plug that into here, and that tells you that FAZ plus 40 minus 80 has to be equal to 0. So then FAZ has to be equal to 40 newtons.
Oh, okay, yeah. I think...
Is that it?
Yeah, I think that's it.
Okay.
We found the support reactions. That's all.
Wow. We did it.
And then the other one that I have is a math
Yes.
one.
Give me the math
And
question.
I do mostly graph
Okay.
theory stuff, so this is a little bit different because this is more function stuff.
Okay,
It's a little bit different.
let's see it. I like
I
graphs.
send it in the office hours.
Yes, cool. Let me pull it in. Ooh, so this is where like I might have to have some of my upper what level math is this? Is probably like college something, right?
Yeah, I'm in 3rd year right now.
Okay. Let f r to r, so it takes real values, it puts it onto other real values, be a continuous differential function with f prime is never 0 for all r. Define g of x is equal to f of x over f prime of x. Good. Prove that f of x is strictly monotonic. Oh, if f of x is strictly monotonic, then g of x is strictly increasing or strictly decreasing depending on the behavior of f of x. Okay. So, monotonic means that it's only increasing or only decreasing then, right? Is that what
yeah.
monotonic means? I think so. Like, for instance, if you have f of x is equal to, like, you know, x squared plus x to the 4th plus x to the 6th, this is always increasing, right?
I believe so.
Yeah.
Monotonic is just always increases or decreases, and never
Okay.
it never changes directions.
Good. Okay. So if it never changes directions, that tells me that f prime of x is never equal to 0. So f prime of x is always positive or always negative.
Yeah.
Okay. So then they say, what's happening to g of x? Oh, yeah, you're right, Enigma. Sorry, yeah, that example was not monotonic. Yeah. You're right. Because the derivative there could be equal to 0 at some other point. Okay. Yes, Enigma, thanks. Okay. So if f of x is always increasing... do we just take a derivative of g prime of x? Is that what... Can we just do that?
Actually,
Right.
yeah, that might work.
Can we just do the quotient rule here? Because this is two things, right?
Quotient rule.
Mm-hmm.
We get f
So
prime
this-
x squared minus fx f double
Good.
prime x
Minus fx f double prime of x all over...
over
f-
f prime x squared. Just
yes,
f prime x.
just f prime of x squared. Cool. Okay. So, this is always positive. This is always positive.
So we just need the denominator always positive. We can get rid of the, right?
Well, so no, I can see this, right? So this is just equal to... This is equal to 1 minus f of x, f double prime of x, over f prime of x squared, yeah? If I just
Okay.
distribute that, I think I can do that, right? And also we said that f prime of x could never be equal to 0, right?
Yeah. So
Okay.
then the denominator,
Yes.
it can't be 0. It doesn't exist. We
Right.
can get rid of that.
Yeah, so this is always positive too, right? Because f prime of x, I don't care if f prime of x is negative or positive, squaring it's always going to be positive. Okay?
Mhm.
So then g of x is equal to 1 minus f of x, f double prime of x.
No, I don't think we can do that because when you cancel them out earlier, you would have
Yeah.
divided by 0. So you can't do the 1 minus all that. I think you have to keep the f prime of x squared in the numerator.
But we said f prime of x could never be 0.
Yeah, I know, but that in the numerator it can be. When you went to the second step where you did 1 minus fx, f
Yeah.
prime of x, that cancellation to 1 involves assuming that f prime x is or it exists at everywhere, but because
Yes.
it is never 0, then we can't have it on the denominator, I don't think. I think we have to keep it as f prime x squared minus fx times f prime of x, or f double prime of x.
Let's see. You're saying this, right?
Yeah.
I know that you can't let this equal to 1 if f prime of x could equal 0, because you can't have 0 over 0.
Oh, am I getting mixed up?
I think you're getting a little bit backwards. Yeah, you are not allowed to cancel this. It's okay. You're not allowed to cancel this to 1 if it could be 0.
If that's 0, but it's not. It's just.
But
never
we said
0.
it's
Sorry.
never 0, so you can actually just write this as
Got it
1.
mixed up.
Oh, good. That's totally cool. Okay. I still got to think about like f of x and f double prime of x.
Yeah.
Ugh. If something's always increasing
Or decreasing.
or always decreasing, does that mean the second derivative can change?
Yeah, I believe we could check if it's.
Oh, because we
concave or
could do this, right? You could have like a titration curve, basically, right?
Yeah.
So this function is always increasing, right? But it's going from concave up to concave down, right?
Mhm.
Okay. Real Master says math's fun. Thank you. So the graph can still wiggle. So this could be positive or negative. Okay. My question is, how does that assure that this will always have to be positive or negative? Because this one minus doesn't really help me out. Let me see. One sec. It's because of the squared on the bottom. Yes, I agree, guys, that I agree that this will always be positive. But then how do I know this is going to be either greater than 1 or less than 1? Because if this is greater than 1, then g prime of x is 0. And if this is less than 1, then it's always going to be positive. What can we say about f of x and f double prime of x?
Wait. I think we can still get rid of the 1 minus here, because the 1 minus is what's tripping me up. If we go back to before we split them up, that f prime x on the bottom is just always positive, so we can just get rid of it if we're only worrying about whether it's positive or negative.
Sure. Okay, let's do that. So let's just get rid of it here.
Yeah.
Okay, so now I have f prime of x squared minus f of x f double prime of x. Yeah?
Yeah. I think that'll be easier to work with than the 1 minus.
Okay. And I want to prove whether this is always positive or negative, yeah?
Yeah.
Okay.
Should we just check for each case?
I'm trying to think. You're welcome, John here. When in doubt, I throw things at ChatGPT and see if it gives me inspiration. Because this is close. I feel like we're close. And I like this question. It's a really cool question, by the way. I'm a fan of this. Found a smart YouTuber. Actually, 1 in a million. Wow. Yeah. Appreciate that. One sec. Ooh. Okay. Yeah, okay. I was almost thinking this might be like a product rule. That's FF prime. Okay. All right. So Vito in the chat is saying that what happens if we take ddx of f prime of x? Okay. So that well, it's close. That would be that would be derivative of the first times the second. That would be f prime of x squared, right? Plus f double prime of x. So it's not exactly it, right? This came from us doing the quotient rule. So do you see how, Vito, it's kind of close.
It's not quite though.
It's not quite though. Where's my dude? I have some math heavyweights in my chat. Penn Center, can you help me? Penn Center, you're my only hope. Penn Center's a math professor, so he's very, very, very smart in math. I'm a physics professor, so math can Fem usually can, or Zach. Zach is also very smart. It's interesting. I threw this. Is it easy? This question is not easy apparently. Because I sent it at ChatGPT 03 and it's still chewing on it, which is always interesting.
We could check. We could check for each case. Like check if x is increasing or if it's decreasing.
Okay.
So like let's just assume it's increasing first and then check for that. Just.
Ooh, Penn Center says he's still thinking. So this is even challenging for Penn Center. Wow. Okay. Yeah. Let's think about something. So you're saying, I wonder if I want to do this with like maybe like a limit definition or something. Oh, what's up, Endar? Endar's another big smart math person. Yeah, Endar.
Okay,
Can you check this for us, Endar?
F prime x is always going to be, if we're going for the first case where it's increasing, f prime x is always greater than 0.
Mm-hmm.
And we could put some more f prime.
But then here's the issue: is so f of x, right? This can be positive or negative, right?
Yeah.
Because
so I think if we just check, if we check for positive or negative of f double prime of x, so if we check whether it's concave or convex, and we just cover all our options there, then we can figure out whether or not g8 prime at x is going to be increasing or decreasing.
It's going to load back. Keep going. All the questions we've done so far. Okay. Oh, and I lost my screenshot. No, oh, there it is. Okay. So Zach says, yeah, proof by cases seems like a good option. Endar says, might have to consider strictly increasing versus decreasing for f of x based on the question. Okay. So we considered the case where f prime of x was always increasing, right? Is that what we said there?
Yeah.
Right.
Okay. F prime of x always increasing, and then to check for the f double prime at x, we can check if it's concave or convex.
Let's say we had a function that looked like this, though, right? This is a function that's always increasing, correct? Okay. F prime of x is always equal. Well, let me make it so it's actually always increasing. But here's kind of my issue with this, right? This is always greater than 0. Cool, that's positive. But f of x can either be negative or positive, right? Based on where it is on the graph.
Mm-hmm.
And then also an issue here is that f double prime goes from being positive to being negative.
I see.
Whereas, so do you see how the concavity is changing, and the concavity changes like based on where it's at? Which makes it super weird, because now let's consider a function that's always increasing and always concave up. So let's say you have a function that just looks like this, right? Let's say it's just y is equal to e to the x. Yeah?
Yeah.
That's a function that's always increasing, so this is always greater than 0. And let's just, it's like e to the x plus 3 or something, right? Now f of x is always positive, and f double prime is also always positive. So now we have positive minus positive positive. Versus here, I had positive, and then it was minus, well, it could be positive or negative, times it could be positive or negative. Wow. Very crazy. Okay. Okay, here.
I think that, I don't know. I don't know what to think here.
Let's see what ChatGPT said. I'm curious. Strictly.
What does it say?
Well, Devil said strictly monotonic. Okay, so here, let's see what this says. It says, okay. They got to the same point we got with this. So they also did the quotient rule. Right? So we got to this, and we said since the denominator is always positive, so we only really care about the sign of this.
Yeah.
Right? We only care of this minus this. Okay. It says if on some interval f prime of x is greater than 0, so it's strictly increasing, then if f prime of x is greater than this, then g is strictly increasing, and if it's less than this, then it's strictly decreasing. Okay. Likewise, if f prime of x is less than 0, so that it's strictly decreasing, then the same inequalities force g to either be increasing or decreasing, but they're reversed in that g prime of 0 now means that g is decreasing.
Okay, that makes sense. Where f is monotonic, then g is also monotonic. That makes sense.
Oh, wait, so wait, was the proof just that it is always increasing or it's always decreasing? Is that literally all it is?
Yeah. As long as f is monotonic, then g is also.
Oh, that's fucking retarded. I wanted to prove whether it was always... I wanted to prove it was always increasing or it was all... But it's like, oh, it could do either.
Yeah, it was just whether it's monotonic or not.
I didn't
That's
get
why
it.
I
Okay.
wanted to check by case whether it's increasing or decreasing, as long as we get proof that it has to be one or the other.
All right. Yeah, Femvox. Femvox says he didn't get it. Okay. All right. It says all right.
And
okay.
that makes it really easy for the rest of it. Concave or convex, we would just compute g, two derivatives of g. We have the first derivative there, so we just take the other derivative. That one seems pretty easy to do. Asymptotic growth. Okay. That one I want to see if we could figure out next.
Okay. And I see, like, yes, some diverging. Wow, there's a lot of stuff going on here. Let me see, Femvox. Does this make sense to you, Femvox, yet? Yeah. What class is this, by the way? For everyone in the chat's asking, like, what the hell is this class?
It's just called functions. I go to a really small university in like northern Canada.
Okay. Oh, Canada. Penn Center's from Canada. He does. I gotta remember what college he's at, but yeah, he's the department math head at some college in Canada.
Okay.
Fembox says I still don't understand ChatGPT's argument. Okay. Let's try to get it for you, Fembox, because if Fembox doesn't get it, then I'm worried. And then here was kind of the other. This was another argument that got made when I threw it at 03.
All I'd say, we're setting up an inequality so that no matter which side of whether the inequality is like true or false for when we set it to be f is increasing and it's concave or convex, the inequality, whether it's true or false, still implies that g prime is always going to be positive or negative, which means that it's also always going to be increasing or decreasing.
Yeah. I think, okay, yes, because if g prime of x is 0 is greater than 0,
it's just never going to be 0, that's all it's saying.
He says it's one of the two cases.
The only how do we know that g prime 0 is going to be 0 is when f prime x is going to be 0, but f prime of x can't be 0 because it's monotonic. That's what ChatGPT is saying.
Okay.
That's just setting up the inequality to make sure that those two are proven.
Okay. Let me one sec. F prime of x can never be 0. So that means it has to always either be increasing or it has to always be decreasing. And then, yeah, the question is like, once you choose a sign, g prime is forced to keep that sign. Yeah, I think that's what we're getting at. Is that once you say, oh, g prime is 0, so if that was true, if g prime was always greater than 0, then f double prime of x squared would always have to be greater than f of x times f of double prime of x. And we know that if it's always increasing, if it's monotonic, right? Well, this is always positive, okay? So then, I get that this can switch signs from positive to negative. So we're just using the if and only if, to ensure G prime keeps the same sign. Yes, I guess that they're making the argument that the logic of this is forcing it. Yeah. Okay. Wow, crazy. That's kind of crazy question. Okay.
That's a neat proof.
It is a neat proof. Yeah, AI is fucking dope sometimes. You got a 5. Nice. Good job, Navs. Okay. Which one you want to help with?
Asymptotic behavior, though. That I think that that for f being concave or convex, g at x, it would be basically the same thing, just applying the same process again.
Okay.
I don't think that one would be too hard. But asymptotic behavior of f at x as x approaches infinity.
Okay. Let's see. I did throw some ChatGPT at this, so let's see what they have. Oh, it says, okay. Equity. Yes, equity. I can do the rest of your questions after this. Is that cool? Equity, if you're still around? My bad. Okay, so g of x is equal to f of x over f prime of x. So that tells me f prime of x over f of x is equal to 1 over g of x. And it says one can integrate to recover f from the knowledge of g. Oh, okay.
Oh, I think I know where this is going. Now, I kind of think I know where it's going. It's going to integrate up to x dt over g, right?
Mm-hmm. Which is ln of x.
Yeah, you're going to get some kind of natural function. And that's going to help you figure that out.
Okay, so yeah, so
you're going to get, as g approaches 0 probably, right? The integral is going to be, like, it's going to blow up way faster than anything linear. So you're going to get some kind of exponential growth. But if you go to infinity, you're going to get some kind of sub-exponential growth, I think. Like some kind of stretched exponential or algebraic something. Depends on the rate, right?
Yes. I see. So they say limit as x... So if the limit as x approaches infinity of g of x is equal to L, then f prime over f is equal to 1 over L. So this is if it has like a finite limit, right?
Yeah.
So then taking the derivative of both sides, yeah, okay, cool. F prime over f, this is the ln of f of x is equal to x over L plus c. I see. If you just integrate this, dx. Okay. And thus, if that's true, then ln of f of x is equal to x over L. Okay, cool. So f of x is then equal to, you're right, this exponential, e to the x over L. Okay, cool. So then f either grows or grows or decays exponentially with some scale. Yeah. Why is it saying g of x is L at 0? So, no. So what it's saying is that if we take the limit as x goes to infinity of g of x, and that goes to a finite thing, then 1 over g of x, Vito, is equal to 1 over L. But that was also equal to f prime of x over f of x. And so then what happens is, if you integrate this dx, this is the same thing as the ln of f of x, and then this is the same thing as x over L plus c. Yeah.
Where are you actually getting those comments from? Is that like something other than YouTube? Is that on like the Twitch chat or something?
No, it's on YouTube. Sorry, it is on YouTube. There's all the YouTube chats coming in. The YouTube's going crazy. I've been doing this now for probably about 4 years, and I've only just started streaming to YouTube Shorts in like the last 3 months, and I've found that it is exponentially better with reaching people at this point.
Yeah, that's actually how I just found it. I was just scrolling through YouTube, taking a break from studying. I saw this, and I'm like, hey, maybe this guy can help me with my statics.
Yeah. Exactly. Yeah. And then here it is. The exposure is so much better than Twitch. We originally started on Twitch because how our nonprofit works is we mainly you help out like kids who like play Fortnite and video games to do math and science. But
Makes
there's like
sense.
there's a limited reach to that, and I just recently started hitting YouTube Shorts, and it's just been ridiculous the amount of reach you get on it. I think YouTube is just
Twitch,
really
I think
trying
is,
to.
I think
Go on.
Twitch is probably the wrong audience. I think YouTube, you're gonna have the algorithm is gonna be a lot more catered towards whatever people want. A lot of people post a bunch of different variety content. So the people who are looking for like, the math tutor or searching up like how to do this on YouTube. Nobody really looks for that on Twitch, but on YouTube, you're gonna reach people who are searching up that sort of stuff.
Yeah. No, and I had the same thing also with TikTok. So the main reason we really grew big in the first place was I make like TikTok tutorial videos, which I also put on YouTube Shorts. But like here's like cute little meme videos on like how to like draw Lewis dot structures and stuff, and the TikTok algorithm is like scary fucking good at knowing what you're doing in your class. So it gets really good because all TikTok cares about is clicks. It doesn't care what the content is. So in this case, it was doing a really good job at finding students who like had this on the test like the next day or just taking it, and then they'd be like, oh wow, this is super relevant. And then that's how they would find us. But yeah, YouTube Shorts has been great. I just found you
Is
now.
there any way? Do you have like stuff in the Discord where people can just ask for help and then people get help?
Yes. So in our Discord, yes, I do have like I mainly address them during office hours, like during these live streams. But if you join our Discord, I'll also link you to all these other awesome math streamers, which I'll put in the Twitch chat. So specifically like e to the 2i pi, which is Zach, he has his own Discord, which is very heavily based on math, and he has like a forum type thing where he'll say like, hey, if you have a question, just put it here. And there are a bunch of other really high level math people that love to come in and just like answer. And then Penn Center also has a Discord called The Elements that he has a similar like kind of a help board where people come in. I'm kind of like a one-man show when it comes into like, if people post questions, I have other people that'll come in and help, but I really just answer them during live streams. Whereas Zach and Penn Center have, I think, much more high-level communities that can help out with especially advanced math stuff like this.
Yeah, because I'm pretty confident in like my graph theory stuff. I'm just not when it comes to like graph theory, linear algebra, that sort of stuff. I'm really confident in my knowledge of that stuff, even into like fourth year and even early post-grad stuff. Just not functions, complex stuff, and anything physics or chemistry as well.
I can help you out with physics and chemistry all day. There's the Discord link for those in YouTube that are wondering. Yeah, and Penn Center's right, yes. And then we have Eric, Ian Stuckey, and Obi, yes, are also in the Elements. And yes, there you are, Obi, yes. Thank you, shout out to Obi as well. Yeah, there are a bunch of like, I would say veteran, older math, I'm old, but, not students anymore, that love to just help out. And if you post questions, they'll just do it. I'm time limited in what I can do. Even in today's stream, I mean, we're already hitting 3 hours. But it's all good. So yeah, if in YouTube, join that Discord link, and then you'll see links to other streamers, or you can just DM me, and I'm happy to answer.
And you said that ChatGPT came up with these answers? That's interesting. I always thought that ChatGPT would be like
ChatGPT
never able to.
No, this is 03 by the way.
Insane.
This is the super dude. ChatGPT is as good as a math grad student at this point. Especially the more advanced algorithms. It's pretty nuts. I use it all the time. I shamelessly, like, I will use ChatGPT to try to point me in the right direction. And then I think the skill in being a teacher is being able to, like distill that into words that make sense. We are older, Obi. Yes, and we do have people from all over the world. Yes, I mean, I got people from Belize, and we had someone from Malaysia we were helping earlier.
Yeah, I had briefly used it when it first came out, and it was like a train wreck back then. I guess
it's pretty
just
garbage.
improved a lot.
It's so good now. Yeah, ChatGPT is great. Don't sleep on it.
I'll check it out.
Yeah. So let's just wrap this one because then I got some other students I gotta help out real quick. So it says divergent case. So if g of x is, if this goes to infinity as x goes into infinity, then f prime over f also goes to 0. Okay. Cool. A typical situation is g of x is equal to x to the p. Okay.
Yeah, this is the sub exponential growth that I was talking about earlier.
Yes.
Gonna be something stretched exponential or algebraic, something like that.
Okay. Oh, I see. Oh, this is cool.
I think I kind of.
This is just the power rule. It's just the fucking power rule.
Yeah.
Right?
I think that the hard part about this is just thinking of integrating in the first place, because I would never get that. The first thing where it's like 1 over g of x and then integrate that, I would never think of that in a million years. The rest kind of follows.
Yeah, the rest follows. Yeah, again, bless you, ChatGPT, for like giving this inspiration, because once you find that, then it's okay. Okay, cool.
Awesome.
All right.
Thanks.
You're very welcome, dude. Yeah, feel free to come by anytime. And then I'll post the calendar for people. That's my personal calendar. One sec. If people want to know when we stream and when other people stream, here's the link for it. So you can see that we're streaming right now. Tomorrow morning, Zach's gonna stream, and then there's all sorts of other things that are happening. So go check them out.
Again.
Cool. What's up, Ethan? Thanks for waiting, dude. Sorry, we got a lot of people today on the stream. We're helping out.
Alright, it's alright. I wanted to talk about something.
Okay. What do you want to talk about?
Well, just last week I got my report card.
Nice, dude. How you doing? How you doing in your classes, man?
Yeah, wait, how can I post it? Where can I post it? Good grades or...
Maybe you can send it to me, but yeah, maybe don't show all your names and stuff, because we have a little bit of a bigger following now on YouTube. See if you can you blank out the names on things, because I don't know, there's like privacy issues now.
I can't. No, wait, I can't. I really can't, but like...
Okay, just send it to me. I'll take a look at it. I won't show it on the stream anymore.
Oh, come on, really, bro? Yeah.
Well, I don't want to dox your fucking teachers, dude.
I don't know how you can dox my teachers, but where can I send them? Where can I send them?
Just DM them to me. Just DM them to me. All
I
right.
was going to send them a good grades.
Ethan wants to dox everyone. Does anyone teach on Schoolhouse? What is Schoolhouse? You guys talking about Schoolhouse? What? Is that like a website or something?
Right,
nice. Let me see your grades. One sec. Yeah. Wow, dude. A+ is in everything. Here, actually, I can pull in a little bit of this, because you don't have names on this. There you go. One sec. Oh, Schoolhouse. Oh, yeah, that's his thing where he wants people to tutor other people. Yeah, that's pretty cool. I've never done that, but that's great for if you want to get, like volunteer credit and shit. That's cool. Nice, good job. Look at this, dude. You got almost all A's. Nice, bro. It's like some good improvement, dog. Yeah, look at this. Wow, look at this. Physics up to an A as well, dude. Good job, dude. Nice, bro.
So now I'm officially done with
and now you're done. Yeah, look at this. Look at this. Your GPA is almost a full 4.0. Congrats, dude.
It is a 4.0. What? It's a 4.01.
Yeah, your GPA is a 4.0, dude. That's super cool, dude. Yes, congrats, dude. You get some claps.
Yep, a lot of work and dedication put into that.
Good. Well, I'm glad. I'm glad the hard work's paying off, man.
Well, that's the end of high school, though.
You graduated high school. Wow, congrats, dude. Zach, Ethan's been in our server for, I don't know, probably 3 or 4 years at this point. You've been here a while, yeah? That's super awesome.
I've been in here for like a freshman from when I was a freshman, I believe.
So Ethan joined us back when like he was starting high school, and now he's graduated high school, and he lives in Belize. So this is like international success.
International? What do you mean international success?
Well, because I'm based in the United States, and you're in Belize, so that's international. Let's see if equity's still.
And also, so I'm going into college, and I have this new goal set in mind.
What's your goal?
I have a goal where I want to try and be valedictorian of the whole college thing.
Wow, that's a good goal to have.
And I'm actually serious about this. Like other times I will make goals, I didn't even try my best to achieve them.
Well, everyone does things in their own time, is what I say. You know.
Yeah. but now that I'm actually dead serious about this, I want
Yes.
to see where my limits are, because the sky is
Okay.
not really the limit for me. I
The
believe that
sky
the
is
stars,
not the limit. The stars are. I say aim for the. Was it shoot for the moon? If you miss, you'll land amongst the stars. Is that what they say?
Yeah, or they say the sky is the limit, but I know
Yes.
there's something beyond the sky. There's stars.
There are stars. That is true.
But yes, I think it will. Will college be harder? When you were in college, was it hard?
Yes and no. You take less you take less classes all at once in college. So in high school, I was taking probably 7 or 8 classes at a single point in time, right? But in college, I only taken like 3 or 4. Granted, those classes are more intense, but to me, I felt it like it was less like scatterbrained, because I was really focusing on like 2 or 3 things really. But why college is harder and why a lot of people drop out is you have to also be an adult. Like you have to know how to like cook for yourself and do your laundry and not party too hard and stuff. So it's
That's easy. Except
well,
for the
good
cooking
for
one.
you. I mean, I partied a lot in college. So like
Oh,
learning how to
gosh.
balance that is sometimes a little difficult, and some people drop out because of that. So I would say like academically it's probably not harder, but in terms of like life, you got to deal with a lot more things.
All right, and last thing,
What's
I
up?
remember when I was in like primary school, there was
Uh-huh.
this classmate who I tagged with in like grade 7.
Thank you,
grade
Fanbox.
7.
I'm wrong. Okay.
And when I look at her school and like her graduate and their graduate class, I see that this same student is not even in the top 25. I came in 9th place for the entire
Wow.
semester.
Yeah, everyone has their own journey,
Like,
dude.
Like I'm questioning what happened to her. Like
Nice.
she
Don't
never
worry
went
about.
that
She probably had something else just happening in her life. Yeah.
low. Oh yeah,
I went from nerd to partying. That's kind of what I did, and then I went back to being nerd. Deconcentrated. Yeah, hardest part of uni is for sure 1,000 just taking care of yourself while also going to school. A lot of times people bring up depression rates, and yeah, it is a sudden shift into adulthood. Yeah. Again, it's not that the courses are necessarily getting harder. It's that you're suddenly having to deal with so many other aspects of life. But I feel like a lot of people are kind of shortchanging this because they don't leave home. And for a variety of reasons, I understand. Like, it's fucking expensive these days to, like, go get your own place. So a lot of people are staying with their parents and going to college. Totally cool. I understand why economically you have to do that. But you're robbing yourself of the experience of having to become an adult. Because when are you going to learn to, like, live by yourself again? I don't know. I think college is a cool, unique, transitionary thing where, like, yes, you have to be an adult and learn to live by yourself, but they still have, like, some safeguards. There's still some rails up. Like, a dorm is the perfect, like, halfway home between living with your parents and living by yourself. Because, yes, you're living by yourself, but you still have, like, a janitor that takes care of the bathroom, you know? Or, you know, I don't know. You have a mess hall. Like, you have a cafeteria you go down to go get food. You don't necessarily have to cook for yourself. It's not that sudden.
Alright, well, you support my idea of trying to become valedictorian for my college. May I remind you that this time I'll be going up against girls, and I've heard that they statistically do better than boys, and they're very competitive.
Girls do statistically do better than boys these days, especially in college. I forget why that is. But they do.
Would you still support me?
Of course I support you, bro. Yeah. We help people all throughout, dude. I mean, learning has no limits, man. I mean, we help students who are in college. I help, like, grown-ass adults who are older than me, you know, going back to take certification exams and stuff. Like, I don't care how old you are. Like, you can always learn.
And I think I was going to say something else. All right, yeah, I'm in computer science. I'm still taking computer science.
Cool, man. Nice.
So I was still doing lots of work, like workloads and non-stop problem solving.
Well, we can help you out with that. Totally. For sure, man.
All right, but I have to go now. I've got to live my life and help other people again.
Oh, good. Well, live your life. Let us know how college is going, dude. and we're here to help you out. And yeah, stick around during the summer. I'm probably gonna give out like a Nintendo Switch or something. So if you want to win some stuff,
I win a Nintendo Switch then. So summer empty possibly.
we're gonna do a summer tournament. Yeah, I just got the confirmation that I'm gonna get some funding for it, so we'll do it. I just got to finish teaching at UCLA.
But I'm still going to be at work. I'm still going to be working.
It's okay. It's okay. You always work hard. You're great, dude. You got it. Okay.
Well,
Here, let me finish this question. Cool. All right, good. Good to see you, Ethan. Because girls get to choose guys, not the other way around. I mean, it definitely seems that way sometimes. I get it. Here we go. Theta A minus beta. Beta equals B to the what? What's a girl? Engineering. Okay, there's a really easy way to get this. If you let theta equal A minus B and phi equal B in that identity in the table. Sorry, are we talking about... Oh, bro, yeah.
That's dope.
Okay, yeah, let me just stop myself right now. Yeah, please. Thank you. I was about to be like, this is about to become the most disgusting, like, I don't want to do this. Trying to fix all this. Thank you, Femvox. Yeah, okay. This makes it much easier. Let's just use this identity. Wow. Life can be so simple sometimes, especially when awesome people like you in the chat help me out. Okay. Hi, sorry for the segue, but quick question. When it comes to calculus, where's a great place to start as someone who has minimal knowledge? Because calculus has a wide range of topics. I mean, the best way to learn calculus is to kind of go in the order of learn limits, learn derivatives, learn integrals, and then there are like side topics in between all of it. There's a variety of like, you know, free online courses out there. I'm pretty sure Khan Academy has one, or even if you just wanted to follow the syllabus of AP Calculus on College Board, they have a pretty good pathway. Calculus is great because it's a math class that has like a story. Like you learn limits to be able to do derivatives. And then once you have derivatives, you know how to do related rates, or you know how to do optimization. And then you learn about like integrals. And then this allows you to find areas under curves, and then it allows you to figure out volumes of revolution. And then with all this, you can then learn about infinite series and how those converge and diverge. So it all builds on itself. So there definitely is like a progression you should follow. And I think a lot of things like Khan Academy and also whatever AP, the College Board AP syllabus, the order they do it in is more or less the standard way. And yes, like everyone else was saying in the chat, strong algebra definitely helps 100%. Yeah, this is why you take pre-calculus before calculus, is there are a bunch of little side skills that you need in order to do calculus that if you don't know, for instance, your trig identities, or you don't know how to do algebraic things, exponent rules, you're going to find that stuff frustrates you more and will prevent you from really learning calculus because you're stuck in the mud of all the dumb algebra stuff. Yeah. Yeah, OpenStax is great. Yep. Yeah, check it out. Yeah. As always, yeah, you always feel free to, like, subscribe to the channel. You'll get all the notifications when we stream. If you ever have questions about stuff, we can go through them. And if you ever have specific homework questions, there's a website down there that you should use. Okay, this one is very easy. Thank you, Femvox, for the inspiration here. But he says, cool. Let theta equal A minus B. Let phi equal to wait, one sec. Yeah, theta equals A minus B, let phi equal B. Okay. Then the tangent of A minus B, so that's theta plus phi, and then phi is B, is equal to the tangent of theta, so that's tangent of A minus B, plus the tangent of phi. Phi is just b. And then this is all over 1 minus, and then that's going to be tangent of a minus b. Tangent of phi, which is just tangent of b. Wow, look at that. That's so cool. Yeah, so this whole thing, which is this whole thing right here, is just equal to tangent of a minus b plus b, which is just tangent of a. Equity, do you see that? Yeah, and for all y'all in YouTube chat, if you want to join our Discord, please do. It's an easier way for you to like get help and stuff. Okay, so yeah, so Equity, real quick. This was the identity, because I think you get this sheet. Equity, do you get this? Do you get this identity on your sheet? Okay, so this tells me what the tangent of like two angles being next to each other is. Okay, so from that, what Femvox came up with was saying that, hey, do you see how this identity, what I'm trying to solve for here on the left, looks exactly like this? But instead of like a minus b, I'm calling that this. Right? And then instead of tangent of b, I'm calling that theta. Because if this is plus minus, that means whatever this is the opposite sign. So this is tangent plus tangent, and then this is 1 minus tangent times tangent. Do you see that? So then all we said was like, okay, cool. Let that thing equal that. Yeah, right. And then whatever, let b equal. I use different colors. I'm sorry, I should make these green. Let me make these green. Color challenge today. And then here's the cool thing, is then tangent of A is, because this is the same thing as tangent of the pink box minus tangent of the green box. And A minus B is just A. Do you see that, Equity? Cool. All right, here, I'll do your last one, and then I probably got to end the stream because we've been on for a while, almost 3 hours and 20 minutes. Okay, here we go. If cosine of theta is equal to 2/5 and theta is between 3/2 pi and 2 pi, evaluate cosecant of 2 theta and secant of 2 theta. Okay. I need one of the half angle things. Okay. I think I'm going to use these. Okay. Oh, wait. I think I know how we do this. One sec. Flip it, use the double angle, rearrange. Yeah. So, cosecant of 2 theta, that's the same thing as 1 over the sine of 2 theta, right? And the sine of 2 theta is equal to 2 sine theta cosine theta. So this equals 1 over 2 sine theta cosine theta. Okay. And now if you build your triangle here, so cosine of theta is 2 over 5, but it's in the third quadrant. Sorry, the fourth quadrant, right? Because we say it's between 3 pi over 2 and 2 pi, so it's got to be here somewhere. And if it's 2 over 5, right? Cosine is adjacent over hypotenuse. That tells me this is 2, this is 5. Okay. So then if I'm solving for this, this is the same thing as 2 squared plus x squared is equal to 5 squared. So this thing is equal to the square root of 25 minus 4, which is equal to the square root of 21. Okay? So if this is my angle here, right, this is theta, then the sine of theta is equal to square root of 21 all over 5, opposite of hypotenuse. Okay. So now you can just plug this in, right? So this is equal to 1 over 2 times, is there a negative? Wait, did I fuck? Oh, negative, thank you. Thank you. This is negative, my bad. Yeah, sine of theta, opposite is negative. Okay, thank you. That's negative square root of 21 over 5. And then the cosine of theta is just 2/5. So, I don't know, this is kind of ugly, but, what's that? 25 over, so negative 25 over 4 root 21. And then, whatever, like, make it look nice with square root of 21 over square root of 21. I just don't want to do it. Well, I guess I could. It's not too bad. So it's negative 25 square root of 21 all over 21 times 4, which is 84. And I don't think that simplifies at all. And then secant 2 theta, that's equal to 1 over cosine of 2 theta, which you got a couple options you get to use. So I'm going to use 1 over cosine squared theta minus sine squared theta. So that's equal to 1 over, so cosine of theta was 2/5, so that's 1 over 4/25. Sine squared was square root of 21 over 5 negative, so then that becomes 21 over 25. Oh, cool. So this just equals to 1 over negative 17 over 25, which is equal to 25 over 17. There we go. Does that make sense to you, Equity? Yeah? How that works? Cool. Nice. All right, good job. Nice. Good question. Yeah, you're very welcome, dude. Okay. Nice. I do gotta go. I gotta teach another student, so let's end the stream. All right, cool. Thank you, everyone, for coming to Actual Education Office Hours. Oh, right, Femvox, you're so right. There's a negative 25 over 7 here. Dude, I keep forgetting all my negatives. Thank you, Femvox. You get so many saves. Also, Obi for helping me out there. Anyways. Yes, thank you everyone for coming by the stream today. I had a lot of fun working with you guys. I'm glad you found us. If you want to learn more, please feel free to join our Discord. It's the best way for you to figure out like when we're streaming and when you can get more help. Otherwise, we do have a calendar that you can always. But some guys have problems. Okay. Anyways, so yeah, we are streaming again tomorrow. Our stream tomorrow will be starting at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. If you ever want to figure out when that is, you deserve a sub. Yeah, thanks, please, yeah. Go mash that fucking sub button or whatever, because that helps us get more exposure so we can help out more people. So I appreciate that. But there's our calendar if you want to figure out when we're streaming again or when any of our other friends in math are streaming again. Okay. All right. If you're watching us on Twitch, I'm going to go raid somebody. We'll see who we're going to go raid. I don't think they let you raid channels in YouTube yet. They really should. Yeah, thanks, man. Thanks, Vito. I'm glad it was fun for you. Glad you guys enjoyed it. Glad it was fun. Who do we got? Science, Mafia, Tina, energy drink rockets, making rocket fuel from energy drinks. It's kind of cool. Okay, here. We'll go say hi to Science. Science is cool. They're an awesome group of PhDs who do education science stuff on Twitch. So we like them. Okay, awesome. All right, enjoy the rest of your Monday. Good start to the week. We will see you tomorrow. Peace out.